It's tiny, it fits in your pocket, and yet accomplishes so many different things for you with a bunch of different tools. Imagine just 10 years ago the batteries that something that would need to power all these apps and tools would look like. It'd be very big, heavy, cumbersome, and yet somehow someone's figured out how to do it all in this little piece. So if we think about implementing that same kind of thought process to even bigger problems, imagine how much better off we would be.
We all need new solutions to energy. We just have to find a way of coming together now and funding these and working together to actually implement some of these.
We need the ability to rethink how we use energy or how we generate, transmit, and store energy in the future. And we partnered with AFWERX, and AFWERX became that front door and the generator of enthusiasm for us.
Anyone and everyone can choose to be more efficient with their energy usage. And so, hey, maybe conserving the fuel usage on one mission is what enables more fuel for the mission that needs it to get someone to their destination faster. It gives us all more options.
At some point, buying more of what you have doesn't make you better. And so we've got to go to industry and say, how can we do this differently?
Rearview mirror small, windshield's big. So we look out the windshield, we say, okay, what are we going to do next? How are we going to challenge ourselves to be, better, faster, more capable, more durable, those kind of things. And we test and we go for it. So on a smaller scale than I'm sure the U.S. Air Force, but Shelby's an iconic brand and performance is our business. If you look at innovations over the years, they almost always started in racing.
Everything we do has a purpose. I used to work with Carroll every day, and he used to come to me and he'd say, you know what, he goes, I love what you do with my cars. He says, do me a favor, never ever put a scoop, a hole, or a wing on one of my cars that isn't efficient. So I think about that every day. So every car that we design here, we try to put efficiency into it. We got this part, now let's go here, let's go here. And it was just a building block, and we still do that today.
My name is Denise Morris, and I work at NASA Marshall Space Flight Center in Huntsville, Alabama. I'm the current challenge manager for the NASA Watts on the Moon Centennial Challenge. When it comes to energy, Earth and space exploration are much more similar than you may think. In space, solar energy is abundant, but it's not always available to generate the power we need. Batteries can help us run vehicles and equipment for space exploration, but we need more robust performance and durability. At NASA, our researchers are working with innovators to accelerate a variety of energy management, distribution, and storage options for exploring the moon and beyond. And to complement those efforts, we're running the NASA Watts on the Moon Centennial Challenge to bring ideas from the crowd that could transform energy for the Earth and also the harsh environmental conditions we have on the moon and beyond.
I mean, energy is extremely important. It keeps us all connected from all over the world and allows us to do what we do. I know, and I love to explore and go out in the middle of the desert and find, hike for hours and hours and hours. And I realize that one of the limiting factors has always been power, because you can only carry so much. And I load up my backpack and carry as many backups as I possibly can, but it would be incredible if we can find a solution for that. It's amazing what humanity has created so far. There is definitely a way that we can find a solution to this.
So the Spirit of St. Louis was engineered to make the first nonstop flight across the Atlantic from New York to Paris. When Charles Lindbergh was able to demonstrate that nonstop flight across the Atlantic was possible, suddenly it became a mandate. Let's go innovate and make that normal. When you can demonstrate that the impossible is possible, suddenly you realize that's a reason to go innovate.
And so the reason that the energy challenge is such an important effort right now is because if we tackle these problems, there are real solutions that we can implement now that will make ripples of impact in our own daily lives.
I think what we're really trying to do here is to say, no, we want to move away from the carbon-based fuels. We're looking for technologies that are going to change society, because if they change society, then they're going to change warfare.
There are solutions that are there and available in the very near term if we build this partnership.
Having more options because of our efficiency while we're working to get more options, power sources, That'll decrease our vulnerability and increase the rate of mission success.
There's just so much out there, and we have a lot to be grateful for.
I hope in 10 years we look back at this challenge and we say, we found that golden nugget.
We can't just get a little bit better, we have to make a huge leap.
Wow, great video. Welcome back. Hats off, Herc, and to the entire AFWERX production team. As we saw from the video, there are so many use cases for what we're solving for here. And so we hope you had a moment over the last 40 or so minutes to grab a snack or some water. And now we'll welcome you back to dive into 3 more critical areas that are crucial to the holistic look at opportunities to improve our energy efficiency. Over the next couple of hours, we'll be unpacking topics like energy data science quality, analytics and reporting, examining how to instill a rapid decision-making, experimentation, and innovation culture inside the DoD's energy initiatives. That was a mouthful. And finally, we'll be discussing ideas around how we can radically reduce dependencies on fossil fuels via our vehicles and equipment. Now, it's my honor and pleasure to introduce our first keynote of this part of today's challenge. She is the Acting Director and Deputy Director for Technology at ARPA-E, Dr. Jennifer Gerby. Dr. Gerby is here to speak to us today about energy innovation and a high-risk, high-reward approach. Dr. Gerby, welcome to our production. Thank you so much for joining us. The live stream is all yours.
Wonderful. Thank you so much for the invitation and the introduction. I'm gonna share a screen here with some slides, but just want to say at the end of the video that I just caught, we are also a racing automobile family, so quite enjoyed that Ford Shelby bit. All right, I want to show you a little bit about a little place called ARPA-E. I've been with ARPA-E for a little bit over 5 years now, and it is one of the most amazing places I've ever been. We have a job, and our job is to decide what problems in energy should be solved and what those solutions should look like, and then give money to people to figure out how to solve them. We are a very high risk, high reward approach kind of place, and I'm going to talk about that a little bit. We do things in spaces where it's too risky for other parts of the DOE to work. We are a very small, lean organization compared to sort of what we do, but I think that's really important for our process. So let me talk a little bit about what our mission is, because at the end of the day, we're all very mission driven, and we actually have quite a broad mission. It's to reduce imports, improve efficiency, reduce energy related emissions. And as you can imagine, there is so much that can fit within that mission, and our portfolio is extraordinarily broad, as I'll show you in a minute. We also have a mission of ensuring that the United States leads in developing and deploying advanced energy tech. And that includes things thinking about manufacturing and use and things like that. So we have some commonalities in our mission. I think I've heard that, the Air Force cares about energy as well. And that's one of the reasons I think I'm here today, is to sort of show you a little bit about what we're all about and help make those links for people to follow up and have conversations where it makes sense. So this is how we think. What problem should be solved and why? What should the solution look like to make an impact? And to be able to do something like this, especially in such difficult technical areas, you have to have technology and market working together right from the beginning. And we spend a long time during program development figuring out the answers to these things before we ever put out a funding solicitation. If it works, will it matter? We are all about impact. We're all about problem solving. But because we are in this high risk area, a big part of this is being allowed to fail and to fail well. So we are looking for these truly disruptive pathways, whether we're looking at something that's very close to market, like sensors, or something very far from the market, like fusion, and everything in between. We are looking for those disruptive pathways. And we put together portfolios of different technical approaches to get there. And a lot of these will fail, and they have to, or else we're not really looking in a high risk area. If they all worked perfectly, then somebody else could have done that. And so I think that acceptance of failure, realizing that you actually learned something, which is that that technical pathway maybe doesn't work, being able to shut some projects down, pivot other projects, plus other ones up. We have this very active portfolio management approach, is really, really intrinsic to what we do. Now, we are really built on a DARPA foundation, which I'm sure some of you are familiar with. So I wanted to just give a picture of, how we are alike and how we're different. There's a lot of similarities, including things like very substantial involvement in tech management. We have these in-depth quarterly reviews with all of our teams. Again, a very flat organization. We give a lot of autonomy to our program directors in terms of deciding what they do, and we pitch and, pressure test everything internally often. Having this level of empowerment is absolutely important, and having a culture that's very collaborative and not competitive. One of the ways we do that is by having term limits. So people come in for 3 to 5 years and then they leave. This is constantly bringing new points of view, new ideas, new topic spaces into the agency, and it really helps with that culture aspect as well. It also means that we hire all the time, but we have special hiring authority so we can do that quickly. We have a few additions to this, and one, as I mentioned before, is this emphasis on market. It's not that DARPA doesn't have tech to market, but we have to think a little bit more broadly in terms of who's going to buy this, who's going to use this, who are the customers, who are the stakeholders, and really sort of involve them in the beginning of this process. Part of solving these problems is forming a community around them, and that's a lot of what we do. It's really important that we do our contracting in-house. Again, we don't use grants, we use cooperative agreements, and they may change, they may stop, they may grow. So all of this sort of flexibility is really just crucial for us. And if I haven't harped on it enough, just to say, tech to market means different things to different people. And we really do have, from the beginning with our, technical development of deciding what programs to do, have tech to market involved. And that's more in terms of identifying potential fatal flaws and key barriers to impact. But at the end, we also help our teams in terms of, we may be helping startups that come out of a university who have never done something like this before, large companies, everybody in between. Different teams have different needs. And so we do what we can to help them because we need to see that tech move forward in order to have an impact. So we, have a steady engagement with investors and things like that. And we have events for our teams and things to try to help them figure out how to move forward. We even put out a new kind of funding announcement called Scale Up, which is actually scaling previous ARPA-E teams, de-risking their scale-up processes so they can get investment because they weren't de-risked enough the first time. So that's a very new thing. And then, I want to explain that our portfolio, again, it's very broad. We have a very good webpage that has all of this on it, by the way, which I invite all of you to take a look at. Because just from my point of view, I would imagine that there's some mutual interest areas here. Electric aviation, batteries, especially from safety and high power draw considerations. We have remote power generation, power electronics, biofuels, et cetera, nuclear. I mean, we're all over the place. And so it really is important for you to sort of understand that, that breadth, and also to understand that you can reach out to us to be connected to the program director in this area who can connect you to teams. Again, we're a relatively small place, so it's pretty easy to do that. And I think that's important because we don't necessarily know what sort of solutions you need. And there's something very exciting, which is that every 3 years we put out a large open solicitation. This is usually 100 million or more. It is completely open. We do not limit it to any target areas because although most of what we do is put together these focused programs, this is really important because there's things we need to do maybe that aren't necessarily big enough to have their own program. This helps us understand the white space that's out there, new things that are happening. It's a pretty big effort and it's very exciting for us. So we put out a teaming list in advance of FOAs, and we have one out right now for a potential open FOA. And so this is so teams can find each other, talk about what they might want to do, etc. And I urge you all strongly to check this out. We also have some videos from program directors just sort of sharing a thought of what's on their mind in terms of a application space or technology. That's just sort of a fun thing that we would normally do at one of our big summit meetings, just to sort of give an idea of here's the type of stuff we do and here's the type of things that we look at. So this website is an important resource, you know, and it's something where you can look and really think about, you know, what sort of things have a dual use between something that ARPA-E is looking for and something that the Air Force needs. Again, I think there's a huge area of overlap. So I think this is a really good opportunity for folks. And, you know, at the end of the day, you know, we're often asked, you know, how do you make an impact? How do you measure that? I think that that's important. That's a really difficult thing to do when you are a high risk, high reward agency, because it may take a long time to see the results of what you funded. This is really starting to happen for us now. So there's a few different things that we can do. One of them is to look at follow-on funding for companies, either that existed or actually were started as a result of ARPA-E work. And we do this in a pretty conservative way. We actually only look at what funding was related to the technology that ARPA-E actually helped fund to start. And we're almost at $5 billion for that. That's pretty decent. That's double what we've actually put out there. This does not include things like valuations, which actually raise this much, much higher. Some of our battery companies in particular have seen pretty big numbers in that space recently. So we're really starting to see this come out. But as you know, that's just one factor. That's just saying, okay, from sort of a company point of view, what was started and what's continuing. But there's a lot of other ways that there's impact, including, you know, just purely on the technical side of, you know, enabling an entirely new way of doing something that then enables something else. And you can sort of follow the chain of patents or, you know, papers to see where that impact was. So we really try to follow these different ways of understanding, you know, different ways that we're having an impact. And so finally, I know this was sort of a lightning quick overview, but, you know, really emphasizing that idea that we have a broad mission and that, you know, we are hiring all the time. We hire program directors, tech to market advisors all the time. And twice a year, we actually have a call for PhD fellows, which are a really important part of the agency as well. And so it's important for us to put the word out because you never know where your next program director might come from. And if any of you are interested, we'd love to hear from you. So that's really what I have for today. There's one thing I want to mention, which is that we have somebody whose name I should have put on here. His name is John Jennings, and he is one of our tech to market advisors. And he is our liaison to all things military. And he is a great person to ask if you are trying to find a technology or ask questions about a program or something like that. You can find his information on our website. And again, his name is John Jennings, easy name to remember. So he can be a great resource for you as well. So I want to thank you again for the invitation to be able to talk about our little agency with you and to find any areas that we have of, you know, overlap or, you know, dual use. So thanks.
Hey, thank you, Dr. Gerby. That was fantastic. Out here in Vegas, my company, we are also high risk, high reward. So we're looking for doctors like you, and we're also hiring as well. So if you ever want to come out to Vegas, just let us know. Right? I'm just teasing. But we were talking about the Shelby earlier, and one of the reasons it was showcased in that video also is because of their movement into electric vehicles as well. So a high risk, high reward payoff for them. But certainly, it's great to hear what the ARPA-E is doing. And it's great because here at AFWERX, we're trying to make those connections and sort of raise the awareness around all these different verticals that are happening across the federal government. So our small, medium, and even large size businesses can get to know those opportunities that are out there. So thank you again for joining us today.
Okay, thank you so much.
All right, now earlier you heard me talk about the great Colonel Charles Brisbois, but we didn't get to show you the video. So now we're going to do so. And just as a reminder, he is the Air Force Disruptive Technology Team Lead and is the driving force behind all of these efforts. Colonel Brisbois, he's currently TDY, like I mentioned, he's preparing for an overseas deployment in support of those ongoing operations. Once again, a reminder to all of us that we still have tens of thousands that are serving downrange. So thank you for your ongoing service, Colonel Beebe. over to you.
Hi, and welcome to the AFWERX Energy Challenge. I'm Colonel Charles Brisbois, go by BB, and I run the Air Force Disruptive Technology team underneath Air Force Futures. The job of Air Force Futures is to look at the Air Force that we want to have in 15 to 20 years and then start building those capabilities so that we have a force that is competitive and leads the world in delivering air power capabilities, right? And so my particular job and my team's job in Air Force Disruptive Technology is to scout and scan for those capabilities and technologies that are going to enable that force. So we look across the FFRDCs, industry, academia, the labs, and we're super excited that we got the opportunity to partner with AFWERX on a strategic challenge that we can bring to you guys, industry, of reimagining energy, right? Like, how do we reimagine our ability to produce, to transmit, to store, and to manage the energy ecosystem? And when I say it's a strategic importance to us, I think it's really important for multiple reasons. The first is from an operational standpoint for the Air Force. We know that our enemies are looking at how we go to war and how we project power, and we know that they are going to do their best to try to cut off our supplies of energy and the ways we transmit energy. And so we've got to be prepared for that, and we've got to reimagine ways in which we generate combat power, or the energy required to generate that combat power. We also know that we, as the Air Force, are subject to the same climate challenges that everybody else is. And we've had recent examples of our bases being challenged by weather events. And so we've got to reimagine how not only we build resilience into those bases, but when those capabilities are destroyed, that we don't just go back in and put in the same infrastructure, we reimagine something that's even better, right? Something that's going to be competitive in the late 2030s, right? And you could say the same for aging infrastructure, another problem that we have. We don't want to just go back in with aging infrastructure and replace it with new old. We want to reimagine what could be, right? And the beauty of bringing industry into this and bringing you guys into this challenge is that we get the best ideas from you, and we get to help you bring those ideas to market, right? And we get to be an early partner that enjoys that capability advantage, and we are helping in many ways ensure that the capabilities and the technologies that you guys are trying to bring to market benefit the United States writ large, right? So I am super excited that you guys have taken the time and the energy to apply for this challenge. From what I've seen so far, we've got some really amazing companies, technologies, and capabilities out there. I would encourage you guys all to engage in this showcase, to work with my team and with the AFWERX team, and I think this is going to be an incredible event. So again, I thank you, and I look forward to the rest of the challenge.
Wow, thank you, Colonel Brisbois. And he talked about some of the bases that have been impacted over the last couple of years. That's what Fusion was about last summer when we did the Base of the Future. And we talked about resiliency, and we talked about not thinking about old ways of doing business, and really building so that we are more sustainable, more resilient going into the future. And on that same note, what we also discovered, and what we've always known, and we got a lot of really good feedback from big name partners that have not necessarily paid attention or been involved with the Department of Defense, was that when we talk about community resilience, and that when we build these bases, and that when we're thinking about reimagining energy, the better we do as a military, the better we do as a Department of Defense, the better the communities are going to do, especially those in which we operate, because the success of our mission is inextricably linked to the success of the communities. So again, Colonel Beebe, thank you again, and good luck on your deployment. We're all excited for those who have the privilege of serving under your command. So now, as they say, variety is the spice of life, which means it's time for some panels. So once again, you get to choose which panel topic piques your interest most. Navigate to the agenda at reimaginingenergy.afworks.com to find the links to webinars where you can explore a discussion on energy data moderated by Frank Sullivan. He's the Chief of Business Development at BrainBox AI. Or you can hear from some policy experts on our energy policy panel moderated by the great Dave Ditota, our Challenge Project Manager at AFWERX. Option 3, if you stay right here, you'll get to listen to an upcoming discussion on energy equipment, moderated by AFWERX's very own Strategic Innovation Officer, Heather Wild. Heather, take it away.
Thank you, John. And I'd like to ask Laura and Scott to join me now. Lauren.
Hello.
So on my panel, I have Lauren Rosenblatt, the CEO of Uplift Solar. She's a lawyer with a history in regulated market issues and oversight. She's specialized for more than a decade in the electricity industry. She's worked on behalf of nearly all perspectives in the electric sector, government oversight of markets, vertically integrated utilities. She's an energy marketer, law and public policy, high demand energy consumer, various emerging energy generation and storage technologies, and now energy renewables investment developer and market entry of new energy technology. She's dedicated to equitable access for all to power and water. Ms. Rosenblatt directs her efforts to manifest business models and technologies that promote outcomes of affordable power for homes and for economic development. Scott Duncan is the president and founder of Conservant Systems, with over 40 years of award-winning experience in controls, instrumentation, mechanical system design, commissioning, and troubleshooting of new and existing HVACs. He is the inventor of the high-efficiency dehumidification system, or HEADS, created at the request of the Army Corps of Engineers to deal with mold, corrosion, and RH control issues, tested by the Corps at over 57% energy savings for the RH control process. Last year, he created a 99.99% effective antiviral version of HEADS that's being designed into several projects as we speak. And Matt Carlson is the Vice President of Business Development for Wybotic, a 20-plus year veteran of technology and environmental product startups. Matt's background includes senior management positions in sales, marketing, product, project management, and business development. He enjoys working at small entrepreneurial companies with exciting new projects and services. Mr. Carlson graduated cum laude from the University of Washington with a degree in business administration. Hello, everyone, and thank you for being here.
Hello, Heather.
Hi, Heather.
Hey. So I would love for you all to tell me in 60 seconds or less, what do you believe is important about energy technology? I'd love to start with Matt.
Sure. Well, I think, energy is critical to everything that we do in life. It's certainly critical to the DoD. So I think, there's so many emerging technologies these days when it comes to battery technology and how energy is conveyed and transferred and stored, that it's just very important that we all stay up to date on what the latest is and that the DoD can take advantage of that.
And Lauren?
Yeah, well, I mean, I agree with everything that was just said, but I think I would add that we at Uplift think that we're moving towards technology that's all-in-one solutions. Oh, sorry about that. Let me turn that off. And apologies. Okay. Apologies. Anyway, we're moving to solutions that are all-in-one. Technology and energy should not be separate or an afterthought. It should be part of our bundled solution. So as consumers think about the way they use technology and devices, they should expect that the energy supply comes with it.
Great. How about you, Scott?
So my perspective comes from a building technology type perspective. One of the things that we run into in forward operating bases is we consume enormous amounts of energy to heat and cool buildings and keep them supposedly dried out, but a lot of mold and corrosion happens. And in normal bases across the country, we waste well over half the energy we spend on air conditioning, which is a huge number. I mean, a building's energy consumption for the HVAC system can be like 40 to 60% of the total HVAC consumption. So we want to try to minimize that. We know we can do it. It's just a matter of funding and timing and convincing other engineers to do the right thing.
Cool. So why do we need sustainability? How about you take this one, Scott?
Sure. So again, my perspective is from the building perspective, but financial and operational issues, like there are only so much money to go around. There's never enough money to keep everything running on a base. The sustainability has to be built in, and we need to start designing systems for the lowest life cycle cost versus the lowest first cost. There's a lot of really high tech buildings that get built with these really weird, unmaintainable systems, and they die in 2 or 3 or 4 years. And then we get mold issues and corrosion issues and things like that, and that's just not sustainable from a financial perspective. Let alone the fact that you've got munitions that are corroding and they're no longer mission capable, and you've got buildings filled with mold and people are living and working in mold, which is really my pet peeve. So that's kind of my perspective on building sustainability.
And how about you, Lauren?
Sure. Well, I mean, as I understand it, the military is facing a growing need for highly distributed and expendable technology, which is going to require more resources, either stretching existing resources further or finding new ones. And for that, you need innovation, and sustainability in a resource-constrained world will drive that innovation. For example, if the military needs to amp up production of a certain technology fast, in order to do so with an energy supply that's reliable and available, it will need fuel diversity, and that will include renewable technology and also energy storage.
Yep.
Thank you. So, Matt, how would you approach designing an energy-based hardware system?
Yeah, so apologies for not being on earlier. Didn't realize my camera wasn't totally on. But so Wybotic, we make a charging system basically for charging batteries, but we do the charging wirelessly. We also make software products, but I think we've taken the approach of really listening to our customers and understanding what it is specifically that they need, and trying to develop a core set of components that apply to all of our customers, and then taking those and modifying them or integrating them into components that can really use a more reliable source of charging. So we started with, again, just kind of some core components, and then figure out how to package those to achieve the goal that our client is looking to achieve.
Okay, so it sounds like you start with the idea, and it's not necessarily something that is energy focused in the beginning. It's taking something that your customer needs and then applying that to energy. Would you guys agree with that? Yeah. Okay.
Yeah, you have to know the end user needs. Like what do they have to have? That's the first thing you have to set out, is what's the goal? What's the end use goal? And that thing has to be alive for the next 20, 40, 60 years if it's a building type scenario.
Yeah. And what are the barriers to renewable and sustainable energy technology adoption? Laura, in solar, that's a huge thing you deal with.
Sure. I mean, I think the main barrier for the military is that operations and equipment and infrastructure have all been built around reliance on fossil fuels. And I mean, that's an available and dependable supply that has served the military well. But when I think about renewable energy, I think about the use case of gasoline-powered cars and how hard it is to transition away from them, in large part because of range anxiety. Nobody wants to drive an EV and end up in the middle of nowhere with no juice. One way that car manufacturers have addressed that is by creating hybrids, which run on gasoline but rely on it less and can also be charged when electric power is available. And as the markets have evolved to accommodate more EVs and more EV users, it's also evolved the infrastructure to support them. The analogy for the military is therefore not to run out, or at least it should not be to run out and build all renewables all the time immediately. I think what the military should be thinking about is to remove barriers to transition, is to imagine and envision what future operations will look like and how they might succeed better with renewable driven technologies. And therefore it can pace its investment in renewable driven technologies, but based on identifying near-term solutions that have applications that work better with renewable power, or even longer term solutions that require a longer lead time for development.
Great. So what are some real life examples of energy technology usage in today's military and government? I'll leave this to Scott or Matt.
Matt, you want to go first?
Sure. So, at Wybotic, again, we deal with batteries every day. And because there's, so much of our military infrastructure is mobile, batteries are pretty critical to how we move to electrification of all of these different types of vehicles and devices that we use. So if portable and local energy sources such as solar and wind can be used, then batteries are even more critical in making that energy available pretty much at all times. So with so many new battery chemistries and all of the lithium variants and some of the existing older technologies like lead acid and NiCad, it's just really a difficult challenge to keep track of the status of all of those batteries and make sure that they're going to function well when you really need them. So, for instance, how many charge cycles does a particular battery have? And is it still going to give me the same 4 hours of life that it gave me when it was brand new, or am I only going to get 3.5 hours out of it? So having the resources to be able to really understand what that infrastructure looks like and how it's going to perform is, I think, really critical.
Yeah. So again, from the building perspective, building envelopes are getting better and better all the time. So you use less energy just by nature of that fact. Getting new technologies into the bases is hard, but AFWERX has been doing a great job at trying to bridge the gap between like great but unknown technologies and getting that in front of the end users. The Department of Defense and Department of Energy are actively pushing technology transfer through the Environmental Security Technology Certification Program, or ESTCP, and the AFFECT grant program. From our perspective is, again, focused on the mold and the corrosion issues. And we have the high efficiency dehumidification system, which again was tested by the Corps of Engineers at Fort Bragg and Tinker Air Force Base and found to cut the energy by 57 to over 70%. We've got 8 of those systems going in at Fort Bragg right now, a bunch of more projects at Fort Campbell in the process. The Food and Drug Administration has an operational lab on Puerto Rico. The Navy has projects in process in Southern California and in Guam. The VA is designing heads into a hospital operating room retrofit project. And those are just some examples of how this technology can help stop the mold issues and the corrosion issues. And again, Heather mentioned earlier, we have a 99.99% effective anti-COVID version of heads that's going into a few places, which is pretty cool. So
that's awesome. Now, this is a personal thing for me, and any one of you that's watching this that has been following along with our Q&As all throughout the Energy Challenge knows that this is near and dear to my heart. So some people may be surprised to know that the military already has energy-based weapons. So how far are we from having Star Trek style laser photon torpedoes and Star Wars style lightsabers? I mean, I know we did have some entries that were like this to the Energy Challenge, but I'll leave this up to the group.
I know nothing.
Yeah, I mean, I can jump in to tell you, I mean, we already see them. I mean, we work in the drone space. Our charging equipment is used to keep drones, recharged on a landing pad, ready to launch at any time. And particularly in the anti-drone space, where you've got potentially a swarm of drones that are coming at you, or you've got a single drone that's been identified and you need to be able to knock that down. It's a threat. We're already seeing weapons like this. You can have, RF-based directed energy weapons that will scramble the signal on the drone, maybe scramble the GPS signal and cause it to either land or crash. But I know the Air Force technology labs, they're developing some other systems for high-powered microwaves. So you may not be able to see the energy going through the air like you do in Star Wars, but there are very highly directed laser and microwave weapons in use today.
Very, very cool. Yes, we are not speaking in any classified information here, so don't worry. We're all civilians. So what is the ROI for energy-based equipment versus its traditionally fueled counterparts? And what factors are there to consider when coming up with that calculation? How about you, Lauren?
Sure. I mean, in any context, when you're choosing an energy resource, there are assessments about cost factors that are not adequately defined by the market. And I think that the most commonly understood example of that would be carbon emissions. But a factor unique to the military, I would think, is the risk of loss of life that comes with supporting the technology in question. For example, I heard a statistic that fuel convoys were responsible for almost half of the deaths of Americans in Iraq. But when we think about ROI, I think what we're really talking about is how long we're locked into the technology before we get our payback. And the military is confronting a lot more highly distributed, diverse arrays of weaponry. And this allows for more targeted investment, which means smaller investment to tailor the technology towards the particular conditions or circumstances on the ground. The beauty of smaller investment means that the payback time is quicker, and it also incorporates the intangible but significant value of experimentation.
Awesome. And I just want to let the audience know that if you have any questions for our panel, feel free to use the Q&A feature as well. So when would someone know, thinking about that ROI, and whether it's a larger investment or a smaller investment, when is the right time to consider investing or installing these technologies? Let's go with you, Matt.
Yeah, I think it really comes down to the specific application and kind of taking a look at all of the cost factors that get involved. You take a fuel-driven drone or mobile robot on the battlefield versus a battery-driven vehicle, and you can't just look at what's the cost of the battery versus the cost of the fuel. You need to look at what is the cost of getting that fuel all the way to the final position, which has a huge logistics stream behind it. So if we can do things where we're deploying renewable, sustainable energy resources in the field so that you can make your energy, store it, and use it right there in the same location, then you eliminate a huge amount of costs on the back end. And I think those are the things that people need to be considering. But there's still going to be applications where fuel is the best, liquid fuels, petroleum is the best option. But you kind of have to look at that case by case, I think.
So Scott, you'd mentioned that your HVAC system is being installed in obviously in places like Guam and other places that have high humidity. Are you seeing that that's easier for adoption? What is the when you're making that kind of case, is that I think you see what I'm trying to say.
Yeah. So basically, it comes down to what's the end use of the technology, right? So we're working on a project out here in Southern California, which is relatively a desert, right? We're relatively dry here. It's even coastal, so it's not super bad, but it's got a fairly quick payback because the other technologies that would do the same thing are so much more expensive. And this HVAC system is 28 years old. It's corroded to smithereens. It doesn't work. The mission is not being accomplished. I can't talk about it, but they waste huge amounts of labor because the RH is not controlled and they can't do maintenance on these things because they explode, if you get a spark. So, there's that comes into play. So we're typically seeing anywhere, like sometimes the technology is less than a 1-year payback. If you're comparing it against other technologies, if you're like a normal type facility where it's just needing replacement and being upgraded, typically be in a 2 to 10 year payback range. But then again, if you look at the other costs, like if you're throwing away millions of rounds of ammo because it was corroded, because it was stored in a warehouse that wasn't relative humidity controlled, the payback is almost instantaneous, right? And if you're looking at the cost of remediating mold inside of a barracks or inside of an office facility, those costs, if you're able to apply that, the payback on doing it right, on controlling relative humidity and getting rid of the mold and corrosion issues, payback is like instantaneous. So those are the problems that we run into because a lot of the energy calculations don't include the other costs, right? The other real costs, like Matt was mentioning, the cost of getting fuel to the front line. One of our teaming partners, he had a study that said 7 gallons of fuel to get 1 gallon to the front line. That's crazy. And Lauren was mentioning more people die getting fuel and munitions and on oil to the front line and water than on the battlefield. So those are huge, huge, huge costs. And if you can get the energy consumption, energy component of that way, way down, and then build smaller generation systems and smaller storage systems, that's kind of like the holy grail, right? Get everything is using the least amount of energy possible and then produce it in the most effective, most efficient way.
Thank you. So Lauren, we have a question that I'm not sure how much you are used to this. Somebody's asking about using blockchain mining for smart grids. Have you seen like this in solar in your experience?
Yes, I have. In the civilian context and in the grid operations world, the energy markets, blockchain is kind of the energy space is has the highest and most direct potential for blockchain. Blockchain is just a distributed ledger and keeping track of where the energy is coming from, whether it got delivered, and who owns it, using the extensive telecommunications that are in place with the energy equipment. Seems sort of like a no-brainer. The one issue is the securing the information as it's leaving the energy equipment and then being put on the blockchain. I'm using terms that I think are a little clumsy because I'm trying to make it real world. But one way to fix that is hardware securing the data itself. So that means, for example, if the solar panel is producing energy, the solar panel has the hardware in it to capture the energy production at the site of production. Therefore, the high security of the data as it gets transmitted across the blockchain and across different wallets starts at the source. And there's never any question whether the source actually produced it. So I do think that technologies, and particularly hardware, have a role to play in what's very much a software-based piece of progress.
Great, as long as they're not like, I mean, I can just see like Doge Solar coming up someday. So got a lot of questions for you about your drones, Matt. So what is your, what is your experience and perspective on flow batteries for remote storage?
On flow batteries, I'm not sure I understand what the flow battery reference is. I mean, there's a lot of, the challenge is that there are so many new battery technologies emerging and other sources. I mean, hydrogen is also another fuel source. We've got fuel cell focused drones that can fly for long periods of time. I think the key is, regardless of what the specific chemistry is, you've got to have some sort of a system that gives you visibility into how that performs over time and make sure that the people that are using it are very confident that it's going to perform the same way the 50th flight that it does the first flight. And so we developed some software tools for monitoring batteries and monitoring how they get charged. That could potentially be another technology that we implement and, you know, customize within our product to recognize what might be very specific about flow style batteries. But yeah, I wish I knew more about them, but unless it's something that I'm misunderstanding the name, I don't have a lot of background with those.
Sure. And this is for the whole panel. Can you offer suggestions on how the Air Force can help enable the nation's progress towards a smart grid?
Wow. So entities like AFWERX, who is out there searching everywhere for great ideas and getting that into the hands of, you know, Air Force, Army, Navy, that is a really great way to start, because there's hundreds of thousands of really smart people out there that are inventing stuff all the time, but there's no way to get it into the right people's hands. And once, like if AFWERX engages in a challenge that says, hey, we need to look at this, they get hundreds, if not thousands of entries going into that stuff, of which it gets whittled down to a few hundred or a couple hundred. And then those technologies can be vetted out and potentially used, you know, commercially as well as just in the DoD. So that's a great way to start. I mean, this is a great program. I mean, I love AFWERX. It's just good stuff.
Cool. Okay, so this is going to be for each of you. Can you each recommend some decent books, articles, and/or media to learn more about energy, technology, and sustainability. So it could be a course, a podcast, a video, movie. I'll start with you, Matt.
Sure. One of the resources that I've used to stay in touch with kind of changing battery technology is batteryuniversity.com. I found that to be just a really good website for if you don't know a lot about batteries, it's written in a way that you can really get up to speed and understand how batteries charge, and then how important it is to have a very good charger and some software to monitor that. But they also kind of keep up to date on some of the latest news on new chemistries that are coming out. So that would be my suggestion.
Lauren?
Sure. I'm going to quickly answer the last question too.
Okay.
About the smart grid. And just say that energy technology is going from big central plant to smaller and smaller. So we're looking at ground up versus top down. And the military has an urgent need for energy systems springing into action in places where there's no infrastructure. And so what I see is that AFWERX and other parts of the DoD are promoting microgrid technology, which requires a huge amount of intelligence. And all of that software and hardware that's going into these nanogrids, picogrids, mini grids are going to operate the larger grids of the future. So the military has often been the sort of ground zero for innovations needed in the civilian world, and this is sort of a classic example. Regarding recommendations on ways to learn about energy and get interested and excited about it, my favorite is the Energy Gang podcast. And I encourage everybody to, there's a ton of episodes. They've got 3 standing panelists, and they do a really good job of explaining technology, policy, and just issues in the electricity world.
Scott?
Okay, so for me, I know a lot about almost nothing. So we do a lot of training for Army, Navy, Air Force, and Coast Guard as far as HVAC systems and stuff like that. So from my little corner of the world, again, I'm just focused on buildings and relative humidity control and getting rid of mold and corrosion and COVID and stuff like that. You can just reach out to me, and we'll be more than happy to do training sessions with your team. We do it all the time. And the more educated the people are, the better off our troops are going to be going down the road. So I don't know if my contact information is a part of this, but I can throw it out there, or if it's out there, if you got it, Heather, whatever you like.
Yep, we'll send that.
Cool.
Great. And okay, so I'm going to close out with this last question. Can you tell us what you are working on and most passionate about, and then also how to reach out to you? So Scott, I'll start with you there.
So my passion is getting rid of mold in our troops' working and living quarters. I hate it. This is why I didn't retire. I live and breathe to solve these problems. And I want to help anybody that can help me, help the troops and our airmen and our Navy people and Marines. I just hate it so bad. It just makes me mad, because our people should not be living and working in mold, and the systems that are being designed and installed are too complicated. They can't be maintained. And that's just it. I could talk for an hour about how mad I am about that stuff. So I'm sorry.
Matt.
Sure. Well, so Wybotic right now is working on a couple things. Our technology is inherently sealed to the environment, being a wireless power transmission technology. The antennas can be fully encapsulated. So we're now working to have the rest of our systems be fully sealable, so that, regardless of the environment you're in, whether it's the desert or a very humid and corrosive environment, as Scott was saying, you don't have to worry about the electronics. And then we're also developing some software tools that we're just about to launch. There'll be an announcement later this week on a new software product from Wybotic.
All right, and Lauren.
Well, Uplift has lots of exciting projects going on, but one of my personal favorites is we're creating what looks like a Roomba for waterways. So the solar panel is the motor control and navigation intelligence for a little boat that goes around and aerates and feeds the fish for aquaculture. And so I love the intelligence aspect and that particular challenge of what we're trying to do with our solar panels. And if you want to learn more about Uplift Solar, we have a website, www.upliftsolar.com.
Well, thank you everyone for joining us. Thank you everyone for tuning in. And I appreciate you all. And thank you again. And John, back to you.
Thanks, Heather.
Thank you, Heather. Panelists, real quick, before you go,
Sure.
It's such a key point that you guys were talking about on the logistics side, especially in undeveloped, underdeveloped region. Setting up fuel cells just reminds me back to the early part of this century with Iraq, Afghanistan, and prior to that, having to set up fuel cells and route fueling stations. And that's going to continue to be a challenge, in these undeveloped parts of the world. And so we've owned the airspace for the most part. We've had freedom of ground movement for the most part. But what happens when we don't? When we don't have that freedom of movement and we don't necessarily have the partnerships with surrounding countries that permit those en route stops. And that's why what we're looking at here with AFWERX, what you were talking about on this panel, those points are so valid. And the more that we can diversify off of the petrol, off of the fossil fuel energy requirement, the more we can be an efficient force that I think we can be. So thank you for your ongoing work on this topic. And Scott, just one question for you.
Sure.
You talked anti-COVID within buildings and within HVAC, and I know you talked about but anti-COVID. I mean, and maybe for the other two panelists as well. How has COVID and just the thought of infectious disease, how has it either reinforced or how has it changed the way that you view the infrastructure of the future?
So it's actually reinforced it because we all know that there's bad things that people can spray around on bases and it can kill people, right? Biological weapons are not going away. Terrorists are going to use them. And it's just reinforced the fact that we really, really, really need to deal with the HVAC side of it. At the beginning of the pandemic, everybody was saying it can't be spread by air conditioning systems, but it obviously can. All the other SARS viruses were spread. Tons of infectious diseases are spread by air conditioning systems. So you have to apply the right filtration. You have to hit it with high doses of UVC. There's other technologies out there as well, but you really, really, really need to build systems that look to the future of there's going to be bad things happening just outside the doors of your base. They don't even have to be on your base. They just have to be upwind of your base, right? So lots of bad things can happen if you're not taking care of the AC side of it. Again, that's my little corner of the world.
Yeah, thanks for that. And with our buildings here, with our restaurants, our casinos, our hotel rooms, we've gone through the exact same thing. And so it's forced us to redesign and rethink, how we would address infectious disease, not just before, but going into the future. So thank you for the additional insight, panelists. It was great hearing from you, and thanks for participating in today's workshop and panel. All
Thanks
right,
for having
next,
us.
Yeah, you got it. You got it. Next up, and I already see the headshots and the smiles on my screen, so I'm really excited about this next panel. We've got some folks lined up that I think many of our industry attendees are going to look forward to hearing from. So our next moderator is Heather Richmond. Heather is Entrepreneur in Residence at BMNT. That's a fantastic title. I love that. And she has gathered some energy investors to join us on this panel. So let's hear just how they're investing in the future of energy. Heather, the floor is now yours.
John, thank you. And I love being the second Heather R moderator in a row. So I appreciate that. No, thank you so much. I am beyond excited about this panel. Just very quickly, as John mentioned, I'm Entrepreneur Residence at BMNT. I'm based out here in Palo Alto, California. I also started something called the Defense Investor Network, which is not so relevant today, but we can talk about that another time. And finally, I had the pleasure of being part of the founding team of something called Elemental Accelerator, which NECA is going to tell us a little bit more about. So I would love for the panelists to go ahead and show their faces. I know them all. I'm so appreciative that they're here today. I'll go with ladies first. NECA, I'd love for you to introduce yourself, tell a little bit about what you're doing at Elemental, a little bit about the program, and a little about your background.
Hello, everyone. My name is NECA Uzo, and I'm the Director of Energy Innovation at Elemental Accelerator. So Elemental Accelerator is what we call a late-stage accelerator in the ecosystem of incubators and accelerators. And we're really trying to help companies with proven technology scale their impacts by investing in commercial deployments, supporting with partnerships and commercial development, as well as offering coaching based on the needs of the team. We are headquartered in Honolulu, Hawaii, as you can see Hawaii behind me, and we've invested in over 100 companies at this point. About half of them are energy companies, and as the Director of Energy Innovation, I manage all of those portfolio companies and lead our due diligence process in terms of selecting our cohort and the strategy for the parts of the energy ecosystem that we want to address. Currently, we give funding for about $500,000 a company, and some of those are dedicated to California, others are dedicated to Asia Pacific more broadly, but we really got our start through the collaboration of the Office of Naval Research, DOE, other large entities, as well as a collaboration with some of the largest utility companies in the world.
Awesome. Nneka, thank you so much for being here. Kyle.
Hey, thanks for having me today. Kyle Teamy. I'm with Breakthrough Energy Ventures. So we're a venture capital fund. We have about $2 billion under management. We invest in companies that can have an outsized impact on climate change. It has a lot of overlap with the discussion with the AFWERX today about energy. Much of what we invest in is energy or energy related. Background-wise, I should also add that on the weekends, I'm in the Army Reserve. I'm a former active duty Army guy, and I'm currently a colonel in the Army Reserve, serving with 75th Innovation Command and supporting Undersecretary of Defense for Research and Engineering. So this is fun for me because I get to talk about two things near and dear to my heart.
Perfect, thank you. Josh.
Hi, thanks for having me as well. Josh Posmentier. I'm with a new-ish venture fund. I guess we're 4 years old now, Congruent Ventures. We focus on early stage venture investments in sustainability-related companies. It's a pretty broad scope for us, but we're often first money into companies in the mobility and urbanization space, energy transition, food and agriculture, and sustainable consumption and production, which includes supply chain and logistics as well. We have, I think, 34 companies in the portfolio that span the gamut from advanced sensing and autonomy to grid technology and transmission generation to new kinds of sensor networks and robotics on the warehouse and manufacturing side of things. So it's a pretty broad spectrum that we tend to be involved with. But again, we're focused on being that typically first check, finding things straight out of university, out of incubators. Some of our companies actually are Elemental Accelerator participants as well, and we've co-invested with Breakthrough Energy Ventures on the other side. So yeah, it's a great ecosystem that you pulled together here, Heather.
Awesome, and you said the exact right next word, ecosystem. So just before we get started, I know that I do a lot of work in defense. A lot of us do a lot of work focused on defense. However, energy is much broader than that. So just as we're talking about, Department of Defense is currently the largest consumer of energy globally. I really wanted us to take a step back and look at the entire ecosystem. I've been in some conversations with other agencies, DOE, DOT, even with Commerce, other services. Obviously, Navy, put money into start Elemental. Industry, including non-traditionals, which I think is a lot of what this group is focused on. Non-traditionals, what we lovingly call startups in the defense space. But then also private partnerships like Activate, which includes Cyclotron Road, Greentown Labs, EEX, all of these. So I've asked the panelists here to really talk broadly and to talk about their entire ecosystem and how they see it, because I think sometimes we get very, very, very focused on a specific application within the military. We will back up and talk some specifics about that as well. But I did ask if Josh would go first and talk a little bit about, when anyone says $1 trillion industry around investors get really excited. And kind of living here in the Valley, we saw a lot of money go into energy innovation and then a lot of money leave energy innovation. What has that roller coaster been like, and what are we looking at right now?
Yeah, so it's been an interesting experience, kind of from the clean tech bubble to now. It's been, I think, we saw the trough of despair, and now we're on the upswing, where it just kind of keeps going up slowly but surely. So I think energy and what we call sustainability, which we used to call clean tech, really spans a broad range of technologies and areas, probably broader than before. So for us, anything that reduces resource consumption utilization, makes things more efficient, it's all inbounds. I mean, just to give you some examples across the spectrum that we invest in, on the mobility and urbanization side, we have, a couple of companies, one on the, fairly straightforward side of things that focuses on EV charging infrastructure, that sort of thing. So not so much making the chargers, but making it easy for fleets to electrify and manage those assets in the same, make it as easy for them to manage those assets as it was to fill buses with diesel fuel. So pretty straightforward, but the devil's in the details. You've got to make that economic, cooperate with the grid, be a good grid participant and not just a burden. And so they're sort of an intermediary, but they're really greasing the skids for that. On the other side of things, we've got, again, in that same category, something in the route optimization realm, which can basically reduce miles driven and hours driven by 20, 30%, just by continuously adapting how routing is done. And so these you don't usually think of as energy centric, but if you eliminate 20, 30% of the miles driven, you've made that vehicle effectively 20, 30% more efficient. So that's a huge thing. And so we spend a lot of time looking kind of not in, say, EVs and batteries, but one step off, where have solutions not really been developed? On the energy transition side, we have some direct generation. We have a geothermal energy company, but most of our work there is, again, one step off. So how do you improve the transmission aspects of the grid? How do you make the grid more resilient? So we have one company that's focused on undergrounding utility lines and telecom and everything else, but more efficient, hard rock boring, for example. Again, not something you'd necessarily think of as right smack in the middle of energy, but all of their customers, everyone they talk to, is focused on energy, routing things underground, makes them more resilient, especially as climate change increases in scope and severity. But obviously for the military, resilience is also key. To other companies in the software space that basically make the grid more efficient and better able to utilize resources at the edge, called distributed energy resources. So again, taking modern software and applying it to the traditional grid, tons of opportunities. Not easy, kind of scary to think about utilities as customers, but there's a lot of return opportunity, and these are very sticky customers if successful. And then on the food side, we do a lot in alternative protein and trying to, again, grow more with less and remediate land that needs to be remediated to grow more food. And then on the last one, on the sustainable consumption and production, we actually spend a lot of time focused on manufacturing as well, because if you think about where energy is used in the world, a ton is used in manufacturing. And while we haven't done anything like, I'm sure Kyle will talk about what Breakthrough's done on the lowest order, so making concrete and steel and that sort of thing, and refining minerals, we have spent a lot of time on the transformation side of things. So we have got a couple of companies in the additive manufacturing world, one in metal, one in polymers. We have one that basically can do sheet metal formation without a tool and die. And these are huge. They can shorten supply chains, they can build on demand, and they can enable very fast iteration, which effectively makes these operations much, much more efficient, and can also onshore things that were historically offshore with long supply chains. So these are, handful of things we do. And as being an early stage investor, we also work closely with a lot of different incubators and accelerators around the country. So Heather rattled off a few. So, on the hard science side of things, we work with a few of the national labs. So Cyclotron Road, Innovate out of Lawrence Berkeley National Lab down the street from me in Berkeley, Chain Reaction out of Argonne and Chicago. We also work with Greentown Labs. We work with Energy Accelerator. We work with Clean Energy Trust in Chicago. Lots of different ones. Innovation Crossroads in Oak Ridge. So tons of great operations have sprung up over the last decade. And so we spend a lot of time working with those groups closely and sourcing from them. So I'll pause there.
No, thank you, Nick. I'm going to come over to you. And I love that, Josh, you actually, so the kind of the definition of this whole week was seeking solutions to create the future of resilient energy production, transmission, use, and storage. I think you hit every single one. And I guess my point in pointing that out is that, I want to make sure that as Air Force and as DoD more broadly is looking at innovating, so much of this work and so much of this diligence, and Nick, I'm going to come to you in a second on that, is being done in the private sector and is being done by professionals that are really, really, really good at diligencing companies. But Nick, you mentioned, and my last comment about Josh too, is he talked about kind of working with utilities and how difficult that is. And I think that DoD might be the one place that can give them a run for their money. So, and not in a bad way, but I think that energy entrepreneurs understand hard, I guess is my point. They understand that this isn't, a quick hit. I mean, they're in it heart and soul. So just, but Nick, if you could talk a little bit about, grid modernization. I know that was a big key point, for Hawaii when we first started back, there was kind of zero or all green by a certain date, and then we went, or no, 60%, and then we went at 100%. But the grid modernization piece and making sure the grid could handle renewable capabilities, I know was a challenge. And also, if you could touch on a little bit how you do diligence your companies, because I think that's something that could be leveraged and could be used, by our DoD.
Yeah, when we started Elemental Accelerator, I wasn't there yet, but about 10 years ago, part of it was thinking about Hawaii in the United States as being one of the most isolated grids, apart from, the islands that the military uses. And at the same time, it being isolated means the cost of everything is just so much higher, including electricity. So there's this push for Hawaii to have more renewable energy. And that happened in an astounding way, that there's just so much rooftop solar in Hawaii right now that they've slowed down net metering and all of those great benefits to solar. But it also means that the grid didn't have a chance to catch up to all the installations of the new distributed generation. So one of our anchor partners, Hawaiian Electric, works a lot with Elemental as well to think about what sorts of technologies can we assist the grid with that fit within the regulatory confines of the PUC in Hawaii. And one of the challenges of working with utilities and working with grids is thinking about who decides what can go on the grid and how it's paid for. So utilities are not just thinking about new technology, but the regulators and their customers, et cetera. So we've worked with in Hawaii on things like microgrids to support resilience. We've talked to these companies around inertia management and volatility on the grid. We've worked on a series of electric vehicle and mobility products, as well as integrating DER management and planning. So one of the companies in our portfolio, specifically Opus One Solutions, which is based out of Canada, was helping Hawaiian Electric as it thinks about how to build the grid, how to harden the grid as more distributed resources come online. And then there's this resilience piece that, the world is changing faster than we could have imagined as it relates to extreme weather. And all of these events that used to be once, every 100 years are now happening every other year or so. So one of the companies we invested in, Jupiter Intelligence, has worked with Hawaiian Electric in terms of doing their long-term planning, taking a look at their assets and climate patterns, and helping them understand how to better do asset management for the system that they have already, and how they need to plan for the system of the future and the weather patterns of the future. And actually, Jupiter Intelligence was just granted a contract with the Air Force to measure sea level rise and do other atmospheric work. So it's great how it's all interconnected.
That's awesome.
Okay, go ahead.
I was just going to ask a little bit about the diligence that the companies go through and how, and feel free to jump in as far as kind of what you guys look for in a company, what you put them through, that sort of thing.
Sure, and we're a little bit different from your typical investor, whereas some other investors get companies on a rolling basis. We look at all of our companies all at once, which is great because it means that we have 9 months of the year to scout for companies, understand what technologies are out there. But once we start our application process, and our application's opening up in 2 weeks, we get about 800 applications. So Elemental Accelerator invests not just in energy, but water, mobility, circular economy, food and agriculture, and basically any climate positive technology. So we're looking at them not just on a sector by sector basis, but thinking about impact as well. We don't take the technical risk of some of the really, really early stage investors. So we do like to see post-prototype products, at least 2 full-time founders. And then if possible, more than likely, we generally have a product in market. So we have 3 tracks, one that's focused on some of the companies that are earlier stage. Maybe they've sold their first product or had their first deployment, but want to kind of get out of that pilot stage. And we have coaching on, fundraising and sales and growth. And the way we think about those companies are around coachability of the founders and the founding team, thinking about their total addressable market, competition, also thinking about their ability to pivot. So many times we have founders who are coming from the lens of X industry, and they say like, well, I have a solution for agriculture. And we turn around based on our knowledge and say, actually, I think you have a bigger addressable market in the world of wastewater, et cetera. So we think about things like that. For our later stage companies, we're looking at the ability to execute. Have they shipped product? What does their capability for project management look like? Elemental does support on project management, so we know that we can link in there, but also as they have their product roadmap, how Elemental deployment and projects can help them scale. And we use the number of 10x, whether that means 10x the number of customers, 10x the number of people who were impacted, 10x reduction in greenhouse gases, you name it. So it's a pretty thorough process for early stage accelerator.
Incredible. Thank you. Kyle, coming over to you. I'm not even sure how much time we have, but we're going to just keep going until someone tells me to stop. So Josh mentioned, manufacturing, minerals. I know you guys get deep into some of the, I guess, deep tech is kind of the thing these days. I'd love for you to talk a little bit more about your portfolio, but then kind of make that jump over to, how some of these things are impacting national security, because you see the world through that lens.
Yeah, and so I mean, from a portfolio perspective, as Josh pointed out, I mean, NECA, like we've all invested together at one point or another. Like we have pretty good overlaps in our portfolios, and if you look at the portfolios for Breakthrough or for Elemental or for Congruent, there's aspects of that also have pretty good overlap with national security issues, with energy security issues, climate security. NECA was mentioning. There's all sorts of interesting ways of looking at that. I think, I mean, to sort of simplify it, I'd say there's kind of three levels to think about. Like one is sort of the macro, like geopolitical level. And that's where private sector investment, trying to deal with climate change issues, like to mitigate climate change, to make the world more resilient. That definitely overlaps with things that are of concern to DoD. There's also kind of an interesting, we're in an interesting time right now because oil is still very, very important to the world. But new technologies like electric vehicles are growing really, really rapidly. And over the course of this decade, we're going to see this situation where oil will still be fairly dominant, but electric vehicles will be a huge part of the market. And so like at a geostrategic level, we used to talk about, like if you said energy security, it just used to mean oil, right? It was keeping the Mideast from being too crazy so that everybody could have cheap oil. Now it's going to be, okay, we still have to worry about oil, but we also have to worry about cobalt, and we have to worry about copper, and we have to worry about rare earths, and we have to worry about a bunch of other things that go into lithium, right? Things that go into electric vehicles are going to have geostrategic importance. And so when you have private investors saying, okay, let's invest in new tech, like we've invested in companies that secure new lithium sources, like find new ways to get these minerals. Another one that's going after new cobalt sources. That is good for the private sector, and it's good for national security, and it's good for the world economy. If you go down kind of a level to the resilience piece, kind of like the national level, or you think about like basing for the Air Force, it's kind of like thinking about how does a community operate, and it's some of what NECA was talking about with grids, right? You want that to be resilient. You want it, like if there's an eruption, it can survive. Like cyber attack, it's going to survive. So again, we're overlapping with what's happening, what the Air Force cares about, right? Like you don't want the whole base to shut down if there's a power outage. You want to be able to continue to operate. You don't want cyber attack to be able to take out your power. And so there's some interesting pieces where what's happening with the utilities, what's happening with the startups we care about intersect heavily there with resilience for an Air Force base. And then if you think about forward operations like expeditionary stuff, that's where it gets a little more challenging, a little more different from what private sector invests in. Like we have a ton of overlap, I think, with the geostrategic stuff and a ton of overlap with like base level stuff. Expeditionary, man, that's just logistic challenges and all sorts of interesting things that get away from what the private sector does. Where I think there can be some interesting overlaps is, you know, next generation engines that are more efficient, right? There's been quite a lot of work in those and in hybrid systems that can extend your supply chain. You know, Congruent and Breakthrough, we've both invested in alternate protein technologies that could potentially actually be used in an expeditionary basis, right? You could actually make food in the field using like leaves and things like that that are inedible to humans. So that there's some creative stuff there that gets kind of interesting, and even water. There's technology out there today that could be used to harvest water like locally in different ways that also help with like an expeditionary force. So I know that it's kind of fun, right? Because yeah, I like just personally, historically, I was at InQtel before I came to Breakthrough. And InQtel, we were investing for national security purposes, mostly on behalf of the intelligence community, but also DoD. At Breakthrough, we're all about climate change. I'm investing in the same stuff. I'm doing manufacturing stuff. I'm doing grid stuff. I'm doing like stuff for transportation. Like there's heavy overlap there.
No, I feel like, I mean, just recently, I guess it was the CEO of Larry Fink over at BlackRock said there's been a tectonic shift towards sustainability focused companies and where they're putting their money in. And if you look at, there was an article that came out, investors managing more than $2 trillion are calling on Texas to stop flaring. It seems like I feel like there's been a tipping point as far as, real investment dollars, and going deep like Breakthrough's doing. So I guess quickly, we don't have much more time, but I mean, is there something off the top of your head that Air Force specifically, but the DoD broadly and government as a whole, even more broadly, can be doing to help, with various resources or, airspace to test? I don't know. Do you have any ideas?
I love the AFWERX SBIR program. I mean, I'll just give it, shout out, good job, claps. Like the Air Force is way ahead of the other services and all of DoD in figuring out how to get dollars to early stage companies and how to get those early stage companies connected to end users. And I hope the rest of the services copy it. It's great. DIU's done good work too. I don't want to like neg them. They're doing good work. And so just I think finding ways to connect dollars to startups and to end users within DoD in as frictionless a way as possible is really the key. And the friction is the hard part, I know. So I see Josh and NECA smiling at that one.
But I'm going to go to NECA to give the Navy a shout.
Totally. As someone who's done a couple of these projects on military bases, there's a lot of friction, but like, trying to figure out how do you streamline funding or streamline RFPs so that, startups have the capability to apply. And then just, I mean, the military is an influencer globally. So when we talk about things like hydrogen airplanes or electric airplanes, just having one or two on the fleet, this is shameless plug, for like Zero Avia and Ampere means a lot. It means that, you're trusting these different technologies and basically signaling to the world that we're going to move towards a carbon neutral or carbon positive fleets.
Yeah, and then just to further chime in on top of both of those good comments, as companies continue to mature and scale, we typically invest in companies pre-product, pre-revenue certainly, and often pre-product. So we have a long road. But as they enter the market, develop products that are applicable, it would be fantastic to have early customers in the DoD. Bases can often act as small microcosms for bigger parts of the grid. Resilience matters a lot more in those scenarios than for a metropolitan area. Although as climate change progresses, that becomes more of an issue also with extreme weather and events. And so to the extent that those are opportunities to collaborate with startups earlier rather than as part of a formal long process RFP that we have to work with a big prime on, that's really interesting. From everything full spectrum, from energy to making parts on site on demand, through one of our advanced manufacturing technology companies. It's all it would be fantastic to have sort of early customers built into that process. So
Awesome.
yeah, thanks.
Awesome. So like 10 seconds each, and then they're going to yank us. But Carolyn, coming to you first, what are you most excited about right now in energy?
I'm excited to be living through an energy transition, right? That's the best part of all, the macro level piece. I mean, I could talk on and on about nerdy points on different tech, but like the macro piece of actually like living through a transition from oil to electricity is awesome.
Awesome. NECA?
I'm excited that like the sci-fi future that we've thought about is actually coming true. And all of a sudden it's way more affordable to have things like electric vehicles. It's way more affordable to have solar. And I'm just imagining all the cool things that seem like super futuristic, like going to space, that are going to just be in everybody's capability.
Awesome. Josh?
Well, it's hard to top those two.
Just be done.
I think it's fun to be on the upswing at this point. Things are economical. There's really a huge opportunity to make money. More CapEx was spent on renewables than conventional fuels over the past 12 months. Those are huge inflection points. So it feels like now that we're past those, we've got a much clearer path to the future. So it's exciting.
Awesome. Well, John, we'll hand it back to you, but thank you guys all so much. I appreciate it. We'll talk soon.
Thank you.
Real quick before you guys leave, we still got everybody on there. First, thank you so much to each of you. Thank you, Heather, for moderating this panel. Josh, you had to go last on the last question, but you answered it pretty darn well. But you guys gave some great insight, certainly in the private sector investment, but also the overlays into public sector. That's what we're here talking about. And I think it was Kyle that mentioned it. We're building a more resilient force, but like was mentioned, a more resilient planet as well. So just a quick question for the four of you. It was mentioned about the other sources we have to protect against. 20th century, it was oil. Now, as we've mentioned, as we're starting to go more electrics, that's going to be more batteries, and we're going to have to mine a lot of the resources for these batteries. And it's not just America that's trying to do this. There's both allies and adversaries as well. And so that's sort of like a micro example, but kind of taking a 40,000 foot view. What's a critical step or two from a national security or geopolitical perspective that we could be taking, or we should be thinking about as a DoD for the next 3 to 5 years to help mitigate and reduce that risk?
I can hop in quickly and say that data and cybersecurity is more important than ever. When I used to work at the utility, we used to do drills on what would happen if someone infiltrated our systems. And even today we heard about attempted poisoning in the water systems. So, we have a distributed system right now. We don't have an interconnected grid or water grid or pipeline system. So you're reliant on small towns and mayors to make decisions on, things of national importance. So trying to figure out, a strategy on cybersecurity as it relates to this critical infrastructure to support, everyday people.
And I'll throw to that comment. So she covered the information, like NECA just covered the information part of the domain brilliantly, like getting more towards physical aspects. Support to new technologies, new companies that are going to unlock additional resource availability, right? So some of these sort of choke points, so to speak, in resource availability aren't really because a particular material is not available. It's because it's just uneconomical to extract it from wherever it is in the world. And a lot of this stuff is actually in the United States just uneconomical. So supporting the development of new technologies to pull those things out of the ground, to pull them out of wherever they are in an economical way, that's huge. Also being one of the first purchasers, right? Because a lot of times a company will come up with a new way of doing something. They'll say, hey, thanks for supporting us on the technology. We're doing plant number 1 now. If you please will buy from us, we can come down the cost curve and do plant 2, 3, 5, N, right? So there's both as an early source of sort of risk capital and as an off-taker, as a purchaser. Those are huge. DoD can have an outsized impact with both of those.
Great. Thank you. Thank you for the response, Heather. Great job. It's great to see you all, and you're welcome back here anytime. So anyways, you got it. So for everyone else, stick around and join us for your second opportunity to network. Please navigate to the agenda at reimaginingenergy.afworks.com and click the networking session link via Wonder to jump into conversations with fellow energy subject matter experts and innovators. You've got about 40 minutes to create conversation and connections, and we will see you back here, it looks like at 16:13 Eastern Time, that's 13:13 Pacific, 1:13 p.m. or 4:13 p.m. Eastern Time. See you in about 35, 40 minutes. 100%
the department better stewards of the types of things.
All right, the yellow box is on me, so that means we're back for our final energy challenges of the day, focused on energy transmission and storage. And I know we've heard a lot about each of those topics today, but I'm going to bring up our next keynote speaker who knows a little bit about both, Dr. Brian Anderson. Dr. Anderson, he is the Director of National Energy Technology Laboratory at the Department of Energy, and he's responsible for managing the complete NETL or NETL complex, including the delivery and execution of the laboratory's mission and national programs in fossil energy. So Dr. Anderson, thank you so much, sir, for being here. The live stream is now yours.
Great. It is absolutely my pleasure to participate today, and in particular because I think it's really exciting what the potential is to collaborate between the Department of Defense, Department of Energy, and all of those who've joined us on this webinar today. And then certainly I know that with the challenge, there were over 1,000 participants in the energy challenges. And so one of the big areas that I see a tremendous opportunity for the Department of Energy and Department of Defense to work together is that the DoD is often such a leader in early adoption, in particular because there are other reasons why the Department of Defense might want to adopt new energy technologies before the private sector. And so there's an opportunity as we transition our energy sector as a whole, there's a real opportunity to allow for iteration on commercialization of new technologies. And so I'm going to highlight today just really a picture of my part of the world, my part of the Department of Energy world. The former Energy Secretary used to call it the Department of Everything because we are involved in everything from nuclear security through the electricity grid that we rely on. And so I'm going to go ahead and bring up some slides today. I formerly had a career as a professor, and I promise not to be a professor today, but to just speak to some of the exciting work that we have going on in the department and at NETL very specifically. And so there are tremendous synergistic opportunities and future energy opportunities as we reimagine what the energy of the future looks like, both from a stationary power generation and transmission standpoint, as well as some highlights from the lab that present some opportunities for fuels and even new propulsion systems that we've been working on in collaboration with the Air Force and other DoD agencies. So in case those of you who are here with us this afternoon are not familiar with the U.S. Department of Energy National Laboratory System, there are 17 of us. The 17 national labs are broken down into the 10 Office of Science laboratories, where we have very large scale user facilities and light sources and particle accelerators and synchrotrons. Then there are 3 NNSA laboratories, the National Nuclear Safety Administration, that's Lawrence Livermore, Sandia, and Los Alamos. Then there are the 3 applied energy laboratories, the Idaho National Laboratory, obviously in Idaho, focused on nuclear energy. NREL, the National Renewable Energy Laboratory in Golden, Colorado, on renewables. And then we are the NETL, the National Energy Technology Laboratory. We have laboratory facilities in Albany, Oregon, Pittsburgh, Pennsylvania, and Morgantown, West Virginia. And then 2 field offices, one in Alaska and Anchorage, and one in Houston, Texas. Now, our history is really quite interesting. Well, and I did leave out one, if anybody was counting, the Savannah River National Laboratory in Environmental Management. So sorry about that, Savannah River. But so for NETL, our history dates back to the Second World War, like many of the national laboratories, but ours is a little bit different. In Morgantown, in 1946, our Morgantown site was founded to do synthesis gas, synthetic fuels from coal at the time, following the Second World War. And the Albany facility was founded in 1943 to develop new advanced materials, particularly for the Navy at the time. Our Pittsburgh facility goes back even farther. It was 1908. There was a spate of mine disasters, and in 1910, our Pittsburgh facility was founded. But since then, we have really merged into one laboratory with 3 sites, all focused on one mission. And that mission for us is to discover, integrate, and mature technology solutions. And you can read the screen, that enhance the nation's energy foundation and protect the environment for future generations. This has been our mission for a number of years, how we can be stewards of our environment, but underpin the nation's energy foundation with reliable, efficient, and resilient energy, not just in the power sector. Our vision, I believe we are the nation's renowned fossil energy science and engineering resource. And when I mentioned fossil energy, one of the outcomes of this challenge is to decrease the dependence of the Department of Defense on our fossil energy resources. And that is in fact what we are here to do as the Fossil Energy Laboratory of the federal government. We have 6 core competencies at the laboratory in computational science and engineering, materials engineering, manufacturing, geological and environmental systems, energy conversion engineering, and strategic systems analysis and engineering. And then finally, in research planning and delivery, this is an arm, as a very unique arm for us at NETL, as the nation's only energy lab that is a government-owned, government-operated laboratory. So we look a little bit more like the NASA laboratories, NIST, and certainly the DoD facilities in terms of being a government-operated facility. And so these competencies that we have and across the top in computational science, engineering, and others, we apply to a number of different programmatic focus areas. And certainly as part of the Department of Energy's Office of Fossil Energy, we focus on advanced coal and carbon and natural gas and oil, with a strong focus on decarbonization and how we can use advanced energy systems and carbon capture, utilization, storage, cross-cutting research, supercritical CO2, and transformative power generation to lower the carbon intensity, the carbon footprint of our existing fossil fuels. Certainly, we have an abundance of fossil fuels in the United States. And then finally, in mineral sustainability, as we move to more and more renewable energy and the intensity that we have within the renewable space on things like rare earth elements and other critical materials like lithium, a strong focus on mineral sustainability. And then the program areas in the natural gas and oil space is a lot in natural gas infrastructure and conventional and unconventional offshore and onshore. And then as you notice across the bottom, we provide support to the department in energy efficiency, particularly in the vehicles program, where we manage a large portion of the department's vehicles portfolio and buildings and geothermal, and a little bit in advanced manufacturing. And then across the grid in energy resilience and operations, as well as cybersecurity, we manage the bulk of those programs for the department. So at NETL, again, we have the core competencies of a national lab system with a research and innovation center at NETL that focuses not just on the fossil space and decarbonization and efficient fossil production and use, but also a lot of work across the entire energy space. And so when we think about the challenges that are in front of us for the department, and then I'll go into some specifics, I think, of some interfaces to DoD, one of the big challenges is how we can decarbonize our energy system. And certainly when we look at the various sectors of the energy system as a whole in the country, and yes, these are a few years old, but we always operate looking back at our previous use. But it was a number of years ago that the transportation sector overtook the power sector in terms of its CO2 emissions. And so we have a reasonably known path forward for decarbonization of the power sector. It's through increased renewables that, yes, are intermittent and variable, but when we couple that with storage and other resources that we can deploy, like natural gas, we see a pathway, particularly when you have carbon capture, utilization, and storage for decarbonization of the power sector. Then when we get to the transportation sector, things get a little muddier when you think of the carbon intensity of liquid hydrocarbon fuels that we use, and certainly and what the Air Force is the largest user of liquid fuels within the federal government. There is a real challenge ahead of us in terms of decarbonizing the transportation sector, because the hydrocarbon is just such a unique energy carrier. And so I'm going to talk a little bit more about energy carriers, decarbonization, and the energy system as a whole and how we treat it as a full energy system. So one of our core competency areas was that strategic systems analysis and engineering space. And in fact, we have one of the leading life cycle analysis groups in the country, where everything from the full environmental footprint, not just CO2 emissions, but land use, water use, and other life cycle impacts of energy production. Almost everything we do has overlaid on it what the environmental impact is of existing technology and the potential into the future. And so we lead our technology development through analyzing the entire energy system, be it the US grid as a whole, or interconnects, or even when we get down to base level energy deployment and opportunities that might exist on something that is a microgrid or a large microgrid or a macrogrid that might be more at a base level. Then another aspect of systems engineering analysis is process optimization and controls, and being able to very effectively control the energy system at a device level all the way through a large system like the grid would encompass. And so as you see, we develop and deploy state-of-the-art best practices for technology modeling, techno-economic assessment, and interoperability of individual components that go into an energy system as a whole. And so that brings me to one example of some work that we're doing in a program is an Integrated Energy Systems Program. It's a tri-laboratory, 3-laboratory effort between Idaho National Lab, NREL, and NETL, where what we're trying to build are some models of tightly coupled hybrid energy systems that includes everything from nuclear reactors, small modulars, as well as gas turbines and coal, concentrated solar, wind, all of the above, with on-system storage that includes chemical processes that might involve low carbon or even net zero carbon chemical fuels through carbon capture, either direct air capture or carbon capture and conversion, utilization, or storage. And so what we're trying to design is really the platform by which all of the existing components that we could put on a grid and couple tightly in a hybrid system can be integrated all together to work synergistically, bringing down the environmental footprint as well as lowering the cost and increasing the resilience of the future energy system. Another specific area that I would want to highlight is for the use of supercritical carbon dioxide. Now, there were a few years ago, a cross-cutting effort kicked off across the Department of Energy called STEP, which is specifically using supercritical CO2 in a power cycle because of its unique thermodynamic properties. This is where I'm not going to, Professor professorize. I used to teach thermo for 15 years. But there's a real efficiency advantage of using supercritical CO2 because it turns supercritical at a lower temperature than water does. But there are some challenges. And some of those challenges are in the compatibility of materials, as well as designing the new types of systems. But some of the tremendous advantages are being able to lower the temperature, as you can see, adding 10 or 20% of efficiencies to a power cycle. And it can actually operate in commercial options in the low 1 to 8 megawatt range. When you look at this particular rotor for this 10 megawatt engine, this is a 39-inch long rotor for the turbo machinery for the supercritical CO2 machine. And so when we think of the options, looking forward into potential options of reimagining the energy system for the Department of Defense, using supercritical CO2 might have a real role to play. Another new technology that we've been working on is in solid oxide fuel cells for stationary power generation. They can operate at extremely high efficiencies and have some very interesting opportunities for fuel flexibility. You see running on natural gas, coal, syngas, diesel, and others. And so they have an opportunity for combined heat and power to modularize and operate at very high efficiencies. But that leads us to the types of fuels that we use. And certainly when we want to decarbonize the energy system, using hydrogen is one way that the point source, the combustion point source, can be decarbonized using hydrogen as an energy carrier. And so we view it as a real key component to decarbonizing the world's energy supply. And there are all kinds of applications for on-site hydrogen generation, as well as ways to provide a feedstock for synthetic fuels production. Another type of energy carrier is ammonia, and we've developed some processes using microwave catalysis at NETL to lower the energy barrier, increase the selectivity of chemical reactions, using microwaves to intensify chemical production. Again, a very flexible technology that can be compact and even field deployed for producing synthetic fuels and even producing energy carriers like ammonia or hydrogen or others. And then one really exciting technology that we've been working on in collaboration with the Department of Defense is in rotating detonation engines or pressure gain combustion. This is a new type of combustion system where it's basically, you see pressure gain combustion if you're combusting in effectively a confined space as opposed to the internal combustion engines that we use, or even a conventional turbine. You can increase the pressure, increase the temperature very rapidly, and then end up with a very efficient burn. And so we built a facility at NETL that is water cooled, and we can run the longest, right now to our knowledge, the longest rotating detonation engine combustion runs of any laboratory in the world. Because of the facilities we have. And this is an area that has opportunities for not just power cycles, but also for use in propulsion systems. And then so the last big area that I'm going to highlight, I'm running very short on time, I'm trying to cram a lot into 15 minutes, is in the area of artificial intelligence and machine learning that we're applying not just to energy systems as a whole, but to build intelligent systems using AI and machine learning in the energy space that can be adaptable, that can adapt to environment as well as to operational conditions. So again, to be able to build the AI and machine learning capabilities either at the computing edge or using them for things like materials design. And so as kind of a closing on this AI topic is some of the areas in computational fluid dynamics and the design and development of new materials for high efficient energy conversion, as well as for applications in extreme environments. And this goes into one of our major key laboratory initiatives in alloy development, artificial intelligence and machine learning, the microwave technologies that I've mentioned. And one of our key laboratory initiatives is in natural gas utilization and how we can decarbonize natural gas, turn it into valuable products, either plastic products or even synthetic fuels that can be used and deployed pretty rapidly into the commercial system. And there are lots of ways to partner with us at NETL. We manage a lot of FOAs for the Department of Energy, but then collaborative work can be done through cooperative research and development agreements and MOUs, and we're really open for partnership across the government and interagency, as well as within the private sector and academia. So thank you very much for the opportunity to talk a little bit about what we're doing in DOE and NETL. And again, thanks. And this has been a great forum.
All right, Dr. Anderson, thank you so much. Do we still, let's see. Thank you, Dr. Anderson. We still got you on there? Great, sir. Hey, thank you so much for that presentation. If I can, I'm looking at some of these questions over here. If I can bounce a question off you, because I mean, I was taking some notes here, more than I took certainly back in college. And I heard several different technologies that I'm familiar with, but a couple of others that I might have heard once or twice and really interested in that. And so as we're talking about decarbonization and we're talking about reimagining energy, and the answer may be we just don't know yet, you know, how do you think about like those 2, 3, or 4 energy technologies of the future that businesses can hone in on? Is there a way to think about that right now?
Well, I mean, one of the huge ones is energy storage. And so I think that it has applications, not just grid scale storage, but in fact, if we're looking for a replacement for the liquid hydrocarbon that has a CO2 footprint when you combust it, you know, what do we have outside of uranium and a nuclear reactor that can contain the energy density of a liquid hydrocarbon? And so that's one of the biggest challenges we have in not just decarbonization, but the flexibility that we lean on today in the energy space, and the incremental advances that we will continue to see in lowering the cost of renewables, increasing the efficiency of all of our energy conversion systems has a tremendous opportunity as well. So that just takes me to the fuel cell space, either solid oxide fuel cells or even polymer electrolytes. The efficiency gains that you see through fuel cells have a tremendous opportunity again to really reimagine what the energy system of the future would look like.
Thank you for that. And one final question: I'm looking around at this setup, and I've got wires and plugs and batteries everywhere just to charge the iPhone and everything else, right? So one final question: how do you see, or how does the Department of Energy, you know, connect some of these technologies with the private sector?
Well, that's one of the great challenges for us at the national labs. I think one of the big ways that the department does it is through the national labs. And the 17 of us all have hundreds and hundreds of private sector relationships. We keep account at NETL, and there are 900 different partnerships that we have across the private sector today. So that's one way, but there's still the valley of death. And so we're working constantly across the national lab system, across the DOE, on identifying the ways that we can have better, more efficient technology transfer from the federal sector into the private sector. And there are still challenges. I think there are opportunities through regional innovation partnerships and really building those innovation networks to be able to connect. It's not just the private sector with the ideas, but how then do you get funding to move things across the valley of death as well? And so one of the major partnerships we have with one of the big oil companies is specifically designed on how we can take technologies out of the laboratory and move them into the private sector and scale them up to scale them out.
Great, thanks for that. We're excited to hear and excited to hopefully accelerate some of these things through that valley of death, Dr. Anderson. So thank you again for spending time with us today. And we hope we get to have you back at AFWERX again sometime soon.
Great, my pleasure. Thank you, John.
All right, Doctor, you're welcome. Okay, pivoting just a little bit, time for our final keynote of the day, but certainly not our final panel or content for the day. But as with many of these different topics, I'm really looking forward to hearing more about one that will continue to open up our minds to some of the technologies that are out there. So I'm pleased to welcome a rising star or a star in his own right in the energy space. He's a 2019 Forbes 30 Under 30 honoree. Dr. Phil DeLuna, he was the Director of Materials for Clean Fuels Challenge Program, which is a world-class 7-year, $57 million collaborative research program focused on Canada-made clean energy technology at the National Research Council of Canada. So Dr. DeLuna plans to share with us the fascinating advancements that are happening in carbon tech. Dr. DeLuna, thank you so much for joining us today. The floor is now yours, sir.
Thank you so much, John, and thank you to the organizers for inviting me to this wonderful event. It's really exciting to see all of the work that's being done in the Department of Defense and also the wonderful presentation just before with the Department of Energy. There's a lot of similarities with the work that's being done there, and I look forward to seeing how Canada can collaborate with the United States in advancing these goals together. So first, a little introduction on the National Research Council. We are the Government of Canada's national lab system. We own and operate 22 national labs from coast to coast to coast. We've been around for over 100 years. The Canadian Space Agency, which is Canada's equivalent to NASA, was actually a spin out of the National Research Council of Canada. And we work on everything, not just energy, but also aerospace, transportation, COVID-19 research, digital technologies, telescopes, security, nanotech, you name it, we do it. We serve really three purposes, three stakeholders: industry, government, and the betterment of Canadian knowledge. Industry, we do research in collaboration with industry to help get these technologies out of the lab and into the market. We do everything from collaborative research agreements to fee-for-service and everything in between. And then we also do work for government, other government agencies. The Ministry of Transportation or the Ministry of Defense will contract us to do testing on electric vehicle batteries in cold climate conditions or under machine gun fire. And we do the analysis to look at how these materials hold up. And then finally, for the advancement of knowledge or for the greater good, of course, we publish papers and we submit patents as well. But we also do work that may not have a market value, but has a public good value. For example, our Digital Technologies Research Center works very closely with Indigenous communities where there are only 5,000 people who speak a language, where a language is only oral, and they help to develop digital tools in collaboration with them to preserve their language. I run a program called the Materials for Clean Fuels Challenge Program. It's actually a little bit of inspiration from the United States ARPA-E programs, where they're mission-driven, goal-oriented programs. Of course, with a Canadian-sized budget, we are a tenth of the population of the United States, after all. But if you could imagine the ARPA-E program combined with a DOE national lab or a DOD national lab, where not only do we give grants and contributions or funding to collaborators, but we also work with them in the national lab to develop the technology. We're really focused on disruptive technologies to help decarbonize Canada, and especially our hard-to-abate sectors. In Canada, our electricity grid is actually relatively renewable or carbon-free. Most of our electricity generation comes from hydroelectricity or other forms of non-emitting electricity like nuclear. But the two largest sectors where we continue to see emissions are oil and gas extraction and other natural resource extraction and transportation. These are, of course, hard to abate sectors because they're difficult to decarbonize with electricity alone. So while the power generation sector will continue to decarbonize through, of course, the outfitting of and deployment of renewables and the advances in CCUS, these other sectors are a little bit more difficult and will require, I believe, fundamental and transformative technologies to attack those emissions. My program has three thrusts: CO2 conversion, so taking carbon dioxide that has been captured either from flue stacks or directly from the air and converting that into fuels, of course, using renewable energy. And I'll talk about that more in this talk. Clean hydrogen production, which is all about using hydrogen as a zero emission fuel. And then artificial intelligence for materials discovery. We're building a new national lab near Toronto where we're focused on combining robotics, artificial intelligence, and high throughput experiments. We are calling them materials acceleration platforms, or MAPS. These essentially self-driving autonomous researching robots that will help us speed up the discovery of the technologies that we need in both CO2 conversion and in clean hydrogen production. But in CO2 conversion, the main emphasis here is, of course, on emissions reductions, but also, quite frankly, the fact of the matter is liquid hydrocarbons are the most dense, and we will need them in the future, whether that's for transportation, air transportation, for defense, or for long-term energy storage, heating in homes, etc. So we need to capture CO2 from the atmosphere if we have any chance of meeting our net zero by 2050 targets, but it's very expensive to do so. The concept of CO2 conversion is once we capture that CO2, can we actually convert it into something that will give us a benefit, where we can actually generate revenue? There's lots of technologies that are looking at incorporating this into aggregates for building materials, or directly using an enhanced oil recovery, supercritical CO2, like what was mentioned before. But I'm really focused on converting the CO2 using renewables or nuclear or hydro into fuels. And the concept here is CO2 to fuels is potentially a way to close the carbon loop when it's powered by renewables. Nature does CO2 conversion through photosynthesis. When you really think about it, fossil fuels is just a really long way of getting fuel from the sun. It goes through photosynthesis, and then plant matter gets compressed and liquefied underground over thousands or hundreds of years. Then we recuperate that, extract the energy, and emit CO2. Now, an exciting technology that is being developed in Canada and in America as well, which is electrochemically converting that carbon dioxide back into fuel, short-circuiting photosynthesis. And the concept is by using, let's say, for example, a reverse fuel cell. If you could take carbon dioxide and use electricity to upgrade that to fuels, renewable electricity, then what you've essentially done is taken those renewable electrons and stored them into chemical form using carbon as the liquid carrier. And right now, the electrochemical CO2 conversion has the ability to convert CO2 into fuels at a much smaller footprint than nature-based solutions. Imagine the carbon converting power of 1,000 trees in a fridge. So why is this important for the Department of Defense or other areas? Really, there are two reasons. The first is long-term renewable energy storage, and the second is on-site generation of fuels. As everyone knows, renewables are intermittent, and as was said before, energy storage is really the holy grail. Well, if we can take carbon dioxide that we, for example, capture from the air, and then use energy to convert that into fuels, we've essentially taken these renewable sources and converted that into liquid fuels for long-term energy storage. Batteries have their limits. They're good for hour to hour, maybe pushing day to day, but liquid fuels really are the best. And then secondly is the on-site generation of fuels. In remote communities, perhaps on aircraft carriers, or when you're deployed in the field, transportation of fuels is a difficult issue. So imagine instead if you could take CO2 from the air, renewables from a solar or perhaps nuclear, small modular reactor, and then convert that into fuels on site for then generation and use. These are really the two reasons why CO2 conversion to fuels and renewable fuels hold a lot of potential. But there are lots of challenges that still remain, and they're really broken down technically into 4 areas. Selectivity, or once you take your CO2 and you convert it into different products, for example, synthesis gas, you can also make a slew or mix of other things like ethanol, methane, methanol, formic acid, etc. How can we make one fuel very selectively, which decreases separation costs? Secondly is activity. How can we make catalysts that convert CO2 as effectively and as fast as possible? Then there's efficiency. How do we lower the energy cost or the over potential necessary to drive these reactions? And then finally, stability, which is how do we ensure that when we deploy this in the field, it lasts for as long as possible and is able to undergo different situations and scenarios, especially matching with renewables and intermittency flux of power. So there are many companies right now that are looking at CO2 to fuels, both electrochemically, thermochemically, and other ways. Companies like Carbon Engineering, which is based in Vancouver, which is doing direct air capture to fuels, or Prometheus and Opus 12, which are based in Silicon Valley, or Sunfire, which is a solid oxide fuel cell company, CO2 conversion based in Germany. The time will tell whether they can really hit the mark in these 4 topic areas of selectivity, activity, efficiency, and stability. But at the NRC, we're working very hard to address these things, and of course, utilizing artificial intelligence as well to do so. So I know that we're running a little bit late, so I'll end my talk there. Thank you so much for having me. And if you would like to reach out or talk about any of these other topics, you can find me on LinkedIn. And as always, Canada is here to collaborate.
Great. Thank you, sir. Thank you for that. Really appreciate you joining us here today.
Thank you.
All right. Now you might have guessed what time it is. It's that time again with 3 concurrent panels who are awaiting your decision. So scroll down to the agenda at reimaginingenergy.afworks.com to make your selection. Your first option is a panel on energy transmission moderated by Roy Ignacio, project coordinator here at AFWERX. If energy distribution is more your style, our moderator, Amanda Caldwell, project manager at The Difference, is ready to welcome your viewership. Or option 3, stay right here with us as we live stream a panel on energy storage moderated by Peter Cataneo, Vice President at Spin Storage. Peter, the live stream is now yours.
Thanks, John. As you just heard, energy storage is the holy grail, and we have a panel here that'll help bring you up to speed on this key area. My name's Peter Cattaneo. I come from a family. My grandfather and father helped build the oil business in the 20th century, and I'm excited to be here in the 21st century trying to move beyond that. And as far as spin, I'm really pleased to see that AFWERX had this beautiful zoom background of an aircraft carrier showing the front end, where in the latest generation, there's a flywheel very similar to what spin builds. It's just in the Gerald Ford class, it's a very expensive one that works perfectly for aircraft carriers. We're doing commercial grade at a significantly lower cost. I'd like to introduce the panelists we have here. We've got Mike Bowman, C.K. Kim, and Shannon Sentel.
Hi, Peter. How are you?
Hello. Good. Hey, Mike. You want to go first and introduce yourself?
Sure, I'd be happy to. So I'm Mike Bowman. Nice to meet everybody. I'm the Chief Technology Officer at GE's Renewable Hybrids business. The renewable hybrid business sits in part of GE Renewable Energy, and our focus is on solar energy, energy storage, and hybrid products. We define a hybrid product as any time more than one asset comes together into a single installation or system. So this could be things as simple as solar plus storage, or even a gas turbine plus storage, or much more complex things like wind plus storage, plus solar, plus hydrogen generation all together. So the more complex, the more we like it. The products we offer are all based on a flexible platform that are made up of standard building blocks. We use these building blocks to design customer-specific solutions. The building blocks are really a multiple input power conversion system, or our inverter, and then a reservoir storage unit. Both of these units are containerized and ready for outdoor use. We focus mostly on larger scale equipment, so anything from several megawatts up to hundreds of megawatts and even beyond if required. On the storage side, we offer both power and energy applications, so very short-term energy demands and long-term storage. So in addition to our hardware, we have a full set of controls and software suite that we use to really unlock the capability of our systems. We start with what we call our hybrid architect, and we use this to fully design systems. This tool takes into account project-specific information like markets and loads and weather conditions, where the system's going in, and then uses that information to design a system optimally around what the customer is interested in. So if it's availability or reliability or return on investment or whatever it might be, we can design what that system's all about. And then once it's designed, we offer a controller. So this controller can control any number of assets, both GE and non-GE. We refer to it as kind of a single layer of control. So our hardware platform is common to all of our assets. So it allows us to have a very efficient system from a control standpoint. And then finally, we have what we call our optimizer system, or dispatch optimizer. And this tool takes our system with our control and determines the most optimal way to run it. So it looks at market conditions or load demand on the system as well as real-time weather conditions, meaning how much wind and solar is coming into the system, and consider what it's forecasted to do, both on a weather and on a demand of the system. And it takes that into account and determines essentially which way the electricity should flow. Should it be in the battery or should it be going out to the demand to ensure you got the system where it needs to be for what is expected to happen in the future. The other thing we do there is we tie that operation back to the life models of our assets. So we can look at consumption of life as we use the system and make a full economic trade. So that's a real quick overview of myself as well as the business and the products I represent. And with that, I'll hand it off to the next panelist.
Yeah, super. Thanks, Mike. CK, you want to give us a brief intro to your background and your company?
Yeah. So hello, my name is CK Kim. I'm the CEO of Himsen Battery Inc., based in Apex, North Carolina. So we are the manufacturer and supply for lithium-ion battery-based portable energy storage systems, mainly used for the emergency power supplies. So everybody is aware of the problems from the conventional gas generators. So because they need the fuels and the generate fumes are causing very toxic, harmful effects to the human body's environment. They're also very heavy and noisy in use. To solve these problems, we launched a lithium-ion battery-based portable ESS in the commercial marketplace last year. So you can find our product in the wallpaper screen behind me. So products are lightest for the highest capacity, so in the entire market. So at least a third or a fifth of the lighter for the same capacity compared with the other technologies in the market. So they are equipped with the multifunctional features like a solar panel, car, and AC, and Type-C and charging options, and car battery charging options, swappable battery pack concept as well. So we have also strategic R&D partnership with the North Carolina State University for implementing smart battery gauging technology, which provide the user-friendly battery monitoring data based on the machine learning technologies on real-time basis. So I personally had about 13 years of the experiences in the lithium-ion battery industry since 2008. So when I first joined Apple as a global supply manager, so I was responsible for sourcing batteries for iPhone then, and with this experience in that network, I established Himsen in 2016. So I would like to address the challenges and also the in the military battery pack applications, lithium-ion battery industry, supply chain, and technologies, which is really the essential part of energy storage space in today's panel discussion. Thank you.
Thank you, CK. Okay, and Shannon, do you want to bring this up? Shannon Centel with Stealth Power.
Thanks, Peter. Hi, I'm Shannon Centel. I'm the Chief Technology Officer for Stealth Power. We're an Austin, Texas-based smart energy company that focuses on turning any type of internal combustion engine off that relies on fossil fuels. Once we turn that engine off, we rely on, as Mike said, in their applications, either a power or energy storage solution to power either vehicles or standalone applications while that internal combustion engine is off. So a couple of different applications there. Imagine an ambulance sitting on a street corner, idling 24 hours a day while waiting on a service call. We go into that ambulance's internal system, manage the power flow and the engine on and off in an automatic start-stop situation, and mitigate the idling of that ambulance as it sits there waiting for a call. One of our largest clients is the Fire Department of New York, the largest EMS system on the planet. About 2 million calls a year, and we save them upwards of about $15,000 a day in fuel and maintenance cost across their frontline ambulance fleet. The other thing that we do are standalone applications. We do standalone applications along the southern border, again, where very large generators would run. We replace those generators with a large storage, more of an energy pack in this situation, and turn those generators off for about 95% of the time when combined with solar. So to wrap that up, we're an intelligent energy company. Like Mike said, we have very sophisticated controls to manage the switching of the energy or the power. We integrate very well with control systems from remote locations. In a partnership with Microsoft, we can make all of our telemetry available to a customer via a dashboard so that they can see all their systems in real time. and look forward to joining. One last thing, I am a retired Army officer, so I do have a little skin in the game here with a fellow sister service, and really do look forward to the discussion here and trying to get us into a period where we can move away from those fossil fueled engines running pretty much everything on the battlefield. Thanks, Peter.
Super, thanks, Shannon. So you can see we've got a great panel. We've identified a few interesting topics here. So maybe Mike, you can kick us off by talking a little bit about what are some of the unique challenges in supporting the military, something I think all of our panelists have some experience with. So Mike, maybe give us some perspectives on that.
That's a great question, and I actually thought quite a bit about it over the past week or so. You know, I look at the military as a kind of a unique customer in that characteristics of like system availability and reliability are of the utmost importance. You know, not to say that other customers don't care about that, but in my mind, when the military puts an installation on the ground and it has a demand on it, it has to be there, right? There can't be any latency, there can't be any downtime, you know, it can't shut off and have to wait for somebody to come in and fix it. So given those requirements, it makes you really think about how you design a system from redundancy and other characteristics that's ensure that it's available when it's needed to be. The other aspect that I would highlight is installability, right? My understanding of the military, I do have a lot of family military, but I've never been there, but you know, both from a permanent installation as well as a forward installation, things need to go in easily and quickly and be somewhat autonomous, right? So when we've looked at our systems, we've taken into account, you know, how quickly can we put a system in? How simple is it to hook up? How simple is it to operate to make the end user's experience that much easier? And to me, that's something that would be really advantageous to the military, especially on the forward front when you're moving very large amounts of people and material around. How simple you can put them back down and get them moving would be critical, I think, from a military specific requirement.
Great. I mean, Shannon, did you have some thoughts on that?
I did. Thanks for that, Peter. And just dovetailing into what Mike said, the ability for any of these frontline folks, whether they be the ambulance force or Customs and Border Protection agents on the border, the reliability for them is the #1 factor. For them to have a system that's in operation with a 99.9 bar reliability rate is something that not only they demand, but they count on it every single day. And I think that Mike hit it perfectly there. And again, to go right with what Mike was saying, not only that type of deployability and installation, but a modular type feel to whatever tech you're putting out there. We used to carry around boxes and boxes and boxes of C-size type batteries to replace batteries and radios and flashlights. I mean, you name it. To have something in the energy storage range or realm that's modular, that you could scale, that's not a C-size type battery would be very advantageous to the military, that's for sure. That's from personal experience.
That's great. Yeah, no, I was reminded on this topic a long time ago when I was a responsible software engineer. I wrote some code for Halliburton for energy, but it was based on a militarized version of the ROLM computers, that militarized data general, that reportedly had a battle mode where you could throw this switch in which you're under fire, and you didn't really care if you took an unplanned interrupt. You wanted it to keep working no matter what was going on. And I think that's an attitude that really is quite different than you have in the civilian world. And maybe to build on this, a related topic that CK brought up in some of our earlier discussion was the question of packaging, because again, it's to meet the military requirements, it's not quite the same. So CK, maybe you want to kick that off with some of your thoughts as you looked at addressing the military market.
Right. I think the most important things military is looking for is safety and also size and weight for the battery systems. Because most of for cases, infantry soldiers carry average 120 to 20 pounds of the gears, and they carry about 20 pound weight of the batteries in general. So this is really heavy. So for the field operations, so not really suitable for the outdoor and also field operation for military people. So I think this is most important challenges because how much you can make the battery system light and also small for the warfare situation. So that's very important. The criteria the military is looking for in the battery systems. And also the safety is also an issue. So to make really safe product, so packaging it with a battery management system, so which can control the safety, that will be really important driver for the military pack applications. But the problem is now for about 80 to 90% of the current military battery packs are made of old technologies, like nickel batteries and lead acid batteries. So which were introduced about 150 years ago, but not lithium ion. So lithium ion is, well, it's not the adequately enough. We need more advanced in the lithium ion battery technology in the future. But by far, this is the most advanced technology in the market in the battery space right now. But how we can solve those problems coming from those old technologies? That's the main solution. The lithium ion is the main solution at this stage. But there's another problem for lithium ion because there's battery cell shortages and concern of the safety. So how we can package them into really small form factors and also light form factors. That's very important. The issues coming in this place. So making it really light. So having really stable battery cell sourcing capabilities, and also making them in the really light form factors. That's the important topic in the future.
Okay. Thanks, CK.
Yeah.
Again, building on that, your point about safety and the security is of course extremely important. And Mike, you had some thoughts building on that in the direction also of the cybersecurity, because in addition to the physical threats, there are also now cyber threats.
Yeah, cyber is a big deal, and I'm sure it's super important to the military as well. But GE's taken this very seriously, and within our renewable business as a whole, we have a dedicated organization around products. We call it product security, which includes cyber inside that. And the whole organization is driven by maintaining availability, integrity, and confidentiality, right? So when we say availability, this is to ensure the system's available and reliable for its intended purpose, meaning somebody can't come in and use that energy for something else. From an integrity standpoint, we say that our data is ensured to be what it's supposed to be, and it's controlled and maintained, right? No one's come in and modified the data to have the system then do something that it shouldn't be doing. And then from a confidentiality standpoint, only people that are allowed to see the data can see it, but ensure that the people that need to see the data can see it, right? You can't have so much security that nobody can get in. So we do things like we'll track full parameters around the system, and we know how every parameter should be operating with respect to other parameters. So if one of them starts to deviate from where it should be, we'll compare associated variables to ensure that that's trending correctly based on external parameters. But if you find that it's not, it's an indicator that somebody might be playing with your system, right? So we can track those and isolate those and very quickly shut down our system so there's not any harm that occurs from those situations. And we've got over 30,000+ wind turbines in the field, many of which have these cybersecurity systems on it. And we've had the unfortunate experience of having people try to hack in and learn from those. So we've baked all that knowledge into our products, and it's as important as the energy being there, right? You need to make sure they're safe. This cyber is a big concern.
Excellent. Yeah, it's getting a lot of attention, and for a lot of reasons. There's already some discussion of the attack this week on a water supply system of all places. So it's definitely top of mind. Closely related to that, the goal of all this security and packaging is the resiliency and having the availability out there. And so Shannon, maybe you could build on that in your experience, because there's a lot of overlap between the first responder space and the military requirements.
Yeah, thanks, Peter. I kind of hit on that a little bit earlier, but you know, with the availability and the reliability rate, but we also, as you said, have to drill down on redundancy in real time. That 99.9 bar doesn't exist just on a straight through system. So in all of our applications, we have multiple redundancies, both at the storage level and at the application level as it relates to the user. The first being do no harm to the system. We're installed in vehicles both on the OEM side and in an upfitter on vehicle side. And then our standalone applications have multiple redundancies built into them, including the cyber line that Mike was talking about, where all the data is born secure, it's transmitted secure, it's received secure, and decrypted at the point of user on the receiving end. So all of those things have multiple redundancies built into them, such that the first responder or the CBP agent that's in the field doing an active op doesn't lose their camera feed in the middle of kicking a door down on a drug or a drug raid or something. So
yeah, no, resiliency is a huge topic. I'm based here in California, where we've been battling it on multiple fronts. If it isn't the fire, it's the flood, and I think everywhere in the world it's become a major issue. Last sort of major topic here we talked about was this has come up as this national. It's been talked about earlier today as the national security issue around the material sources supplies. And I know it's a focus area for us, both in the design of our products and also our design and the go-to-market to work with different partners. And it was very encouraging to hear earlier discussions about Air Force focus on the carbon fiber supply chain, which is one of the areas we rely on, where they're looking to accelerate that to make all their aircraft and vehicles lighter. It can also benefit them in the storage area. But maybe CK, you could talk a little bit about that, and maybe everyone can jump in, because it's a pretty broad topic, and you can come at it from many different perspectives.
Yeah. So yeah, thanks for bringing that up. So I briefly talk about battery cell shortages just before. So I think this is really critical problems in the world, not only for military applications, but in many other different application market. So now the battery, for example, as the main source of the energy storage system. So there are only 3 countries actively producing battery cell in the world: Korea, and China, and Japan. So they have a major technology sources, or they control about 90% total battery cell volume in the world, and about 6 manufacturers like Samsung, LG, ATL, and Panasonic, and Vision. So they control 90% total market. So which means it's getting more and more difficult to get a really good battery cell, so that they can make really reliable battery cell, and also to make really high energy battery market, to make all the battery system really light and small. So how we can solve those problems, that's going to be really important, difficult issues. So I've been recently talked with the LG Chemical. They're the largest cell supplier in the world. They're based in Korea. They are selling, they have a contract with Tesla for selling their 1 billion battery cell this year. So that really is a really big problem for the other application market, including us in military application. Getting good battery cell is really getting more and more difficult issues in the future. So, but it is also risky to build really immediate battery cell sourcing capabilities. So with a good volume immediately right now. So I think it will take about several years to go. So how we can address those issues? I think it's important to have a partnership with the battery cell manufacturers. So from Asia right now, so that we can get really good sourcing, good battery cell sourcing first place, and we can long-term basis. So with the strategic cell sourcing agreement, and also with the battery pack manufacturer who can really understand the battery cell and how to package them in the right fashion. That's going to be really important thing. So supply chain management is a key important issue in this marketplace. So finding good source, battery cell and packer, then I think we have to really delve into those important agenda. So in the near future, we have really reliable battery pack sources for the military market right now.
Okay, super. No, thank you. So I think we're up on our official time. I'm sure that we would have, if we can squeak in another comment or two, Mike. I think GE has some opinions in how to manage some of these things.
Yeah, I'll follow on quick to just add to what some of CK said, both now and a comment he made earlier. The way we're approaching it is not to tie our systems to a specific battery, because we do need to get better than lithium ion today. We can't be captive to specific suppliers around the world, because you get too dependent, and it's not, there's no benefit to the end customer around that. The other interesting thing is the battery area is so exciting. I mean, the amount of developments that are going on, even at the university level, we're going to continue to see new technologies come out every 12, 18 months at some pace like that. And what you really need is a system that can keep pace with that. So we put a lot of effort into just structuring our product line that, as these batteries come available, we can just roll with that. And that way, we get the benefit from being out there with the new stuff, and the customer gets the benefit that the systems they put on the ground can take benefit from that, because it is a concern. It's a supply chain management, just like CK said.
Of course. So yeah, we have to measure the supply and demand at the same level. The demand is really great. We have to look for many different sources, not only for battery, but others as well.
And the one thing we can't forget, Peter, in all of that is once, if there is a conflict, that resupply chain be a dedicated chain. So everything's going to break once the conflict starts. So needing a replacement part is just as important as having it when you initially deploy the equipment.
Sure, absolutely. And I know this is a global concern. A lot of the people, I mean, I've done business globally, and in Europe, they're painfully aware of the situation they're in terms of having almost nothing right now, and so I think it's going to be a really top of mind topic. And there's so much research going on right now, Mike. I think the approach of flexibility, and if you caught the earlier session on the ARPA-E group, these are areas where they're really putting a lot of efforts into making available as much technology as possible to solve this with more than just one product in one supply chain, because that can always become brittle going forward. Okay, we're officially 3 minutes over. I don't see anybody pulling the hook on us, so I'm all for taking the time.
Hey, Peter.
There you are.
Yeah,
we'd love to keep going, but
no, trust me, I want to stay with you guys all day, because these are some valid issues that we face. I mean, in business, but also out of the front lines that you guys are solving for right now. So I hate to interrupt, but we do have to bring at least this part of the challenge to a close.
Okay, great, thank you.
No problem. And no, thank you, Peter. Thank you to you and the panelists. Really another great conversation and thoughts around energy storage and contingency planning, which we continue to hear the importance of that, diversification, redundancies, resiliencies, sort of continues to reinforce this, on an all of the above type approach. And your panel, it wasn't the first to mention how significant a concern cyber and cybersecurity and the hacking threat is, and it has been for a decade and a half, 2 decades now. And we continue to say, this is a threat, it's a threat, we got to handle it. And we're trying to handle it, but we know that as oftentimes as we come up with countermeasures, the adversary gets a vote too. So again, Peter and panelists, and I know Amanda and Roy from the other panels and their panels, they're back too. So thank you again for spending time with us today. Okay, now transitioning here to our next panel, moderated by Craig Yogi Levitt. He's our innovation strategist and advisor at AFWERX. This final panel features a great mix of joint military and international partners. Our panelists will be diving into how multinational and allied partnerships will not only strengthen, but facilitate our arrival at our energy efficiency end goals. Yogi, we always look forward to a conversation facilitated by you. Please take the floor.
Hey, thanks very much, John. It's a real privilege to be here. We do have a fantastic panel. What we're going to be talking about today is how the joint military force and our allies cooperate towards achieving these very important goals in technology advancements with respect to energy. So I'll quickly introduce everybody and we'll get right into the conversation. To start off with, we have Mr. Rob James. He's the lead of business development for Canada's National Research Council, an expert in photovoltaics and laser beamed energy. Additionally, we have Dr. Michelle Anderson out of the Office of Naval Research. She particularly looks at energy conversion and storage, unmanned undersea and air systems, propulsion, lithium-ion battery safety, and cyber-physical secure resilient grids and microgrids. Dr. Ken Schmieder from the U.S. Naval Research Laboratory manages a portfolio including high-performance photovoltaics, laser power beaming, engineered substrates, and neurophotonics. And I got to admit, Ken, I had to look that one up, so very impressive. Miss Elise Joseph out of the Army Futures Command, the portfolio director for power, energy, and propulsion, working across all of the Army's modernization programs and priorities. And finally, and last but not least, Lieutenant Colonel Nate Chang out of the Air Force Futures Office, the Deputy Lead for Disruptive Technology, and really represents our sponsor today, as Air Force Futures is pursuing technologies to define the future force for the Department of the Air Force, including the air and space forces that we have in the department. So welcome to all of you. It's really my privilege to be on the panel with such a distinguished group of people working in such an important field. So let's get started. I want to ask, we'll ask a couple questions and make sure everybody gets a chance to talk here. First thing I'd like to talk about is where do you see the biggest opportunities to pursue these advanced technologies, and what are the major challenges that are perhaps encumbering achieving these new energy objectives? In particular, with these AFWERX challenges, we do like to look at where those challenges and difficulties lie, so that we might be able to engage with whole of government to try and knock down some of those barriers. So let's start off with Ken. Would you like to talk about that?
Sure. Thank you very much for the invitation to speak today, and thank you to Yogi for the introduction. So addressing this question and thinking about this audience today at AFWERX, I see a potentially high value opportunity in space-based photovoltaics. So historically speaking, the metric of importance and indeed the focus of most innovation has been on improving the specific power of space-based photovoltaics. So what does that mean, specific power? That means improving the watts per kilogram. So either increasing the power output from your solar array or reducing the weight. And in a perfect world, you're doing both. And this can enable longer mission durations in more extreme radiation environments for your satellites, or just satellites with more bells and whistles when all of a sudden you have more onboard power. So what currently slows down improvements, I think, is a combination of, one, the tech is frankly just challenging, and two, it's still something of a bespoke or a niche market. But looking forward, with the advent of reusable rockets, as well as public and private interest in massive small-sat constellations such as the proliferated LEO, that's low Earth orbit environment, I think a paradigm shift will occur in this sector. And instead of needing innovation in terms of watts per kilogram, and to be clear, I'm referring to this specific application. There's always going to be a need for improved watt per kilogram in space, I think. But for this sort of thing where we're doing a proliferated LEO environment, I suspect the bottlenecks will involve the solar array cost, as well as, and this is a real big one, manufacturing throughput. And so the question in my mind is how we can best foster innovation for these future needs so as to mitigate any growing pains along the way. And I think this kind of thing is mutually beneficial in the public and private domain. And I am happy to say that we have started taking steps in this direction through a manufacturing science and technology program that's just kicking off. But I believe a sustained focus will be important as there is a clear opportunity as well as a need for innovation across multiple dimensions. Hey, Yogi, you're on mute, and I see your mouth moving.
Thanks. That had to happen. Rob, in particular, you're working on high performance solar as well as energy beaming. So I think that might be a good transition here for you to talk.
Thanks, Yogi. Yeah, so thanks very much to AFWERX and US Air Force and all the partners across DoD that are participating today. It's a great opportunity. I'm very pleased to be here. So thanks for that. So just to provide a little bit of context. So I'm with the National Research Council of Canada, which I'm sure many people on the webinar here are familiar with. It's Canada's premier research organization for the Government of Canada. About 3,700 scientists working across 178 different buildings in 72 locations across the country with about a budget of about 1.1 billion per year. So minuscule for US Department of Defense, but relatively large for in a Canadian context, right? So I'm really coming from a perspective of the intersection between the energy needs of US Department of Defense now and in the future, and a very climate and environment focused lens on that. So I work for the Energy Mining and Environment Research Center within the National Research Council, where we really are trying to tackle some of the most pressing, challenging problems around energy, climate, mining, and clean tech development that's really going to generate the new technologies that are going to help us to address the climate change challenge. So NRC does a lot of collaboration across DoD in a number of different areas, including with the Air Force. And I think the intersection that really becomes paramount in these kinds of conversations is where we look at where we need to go on climate policy towards net zero, what it will take to get us there, the sheer amount of innovation that's still needed to get technologies out of the lab and into the marketplace in order to steer us towards that net zero by 2050 goal, and how those technologies can be applied in a Department of Defense kind of setting. So I think the real challenge that we're seeing is that, when you move from achieving emission reductions through the low-hanging fruit, through the marginal reductions that you can achieve through wind and solar, and you try and start to get at the deep decarbonization that's needed across the really hard to decarbonize sectors, whether it's cement, steel, heavy freight transportation, those technology areas are where we're really going to see some interesting developments over the next few years. And I think those are the areas where you start to see not only the environment, the climate and carbon reduction impact that you need to see, but also being able to provide the operational requirements for a lot of the applications in the defense space as well. So lots of challenges there to get the right talent working on that, to get supply chains aligned around that long, deep decarbonization pathway. But I think there's some really interesting synergies between where we can go in that space and where those kinds of deep decarbonization technologies can be applied to address the massive carbon footprint in the defense sector as well.
Great, thank you, Rob. Michelle, from another Navy perspective, we're what can you tell us about what you're working on and where you see the common ground amongst the other panelists here?
Sure. Yeah, I guess one great thing with the Navy is that we cover everything because we have the Marine Corps. So everything from individual warfighter power all the way through aircraft and shipboard power. And with the Office of Naval Research, we support the Navy's science and technology portfolio. So everything from fundamental research through prototype development and demonstration. And so the couple of areas where I see the most opportunity really for emerging energy technologies is in unmanned systems. That's primarily because we expect to be procuring a lot more unmanned systems in the future. It's a lot of vision for how we're going to be able to project force and have it be a force multiplier. And it's much easier to insert new technologies and emerging technologies in something like unmanned systems that's a new capability area than it is retrofit for older things. And the unmanned space is very interesting because it's also the entire range of small insect-sized vehicles to large unmanned surface and undersea vehicles. And some of the challenge we're encountering there is you have both very significant weight and size constraints, but also very demanding environmental conditions. And we want both very high power and very high energy density because we have more capable payloads that require power, but we also want endurance. We want those systems to be able to be on station for a very long time. We've been looking at things like fuel cells because batteries alone aren't going to address that for some of the applications. A challenge with fuel cell systems is they need to be refueled. So the ConOps and the logistics of refueling those systems is an added burden to looking at something like that versus battery. Some of the unmanned surface vehicles are also using engine technologies. So that's still logistics fuel. You still have to be able to fuel those systems. The other big opportunity area on the Navy side is shipboard systems. We've been designing small ships with a lot more capability and exponentially increasing power and energy requirements. So fitting that onto a ship, and especially that's a manned platform with sailors, safety is paramount. And again, very significant weight and size constraints. We also can't afford to take decades to develop and implement new technology. And I think that's where there's a big opportunity for industry to be a lot more engaged, especially non-traditional providers, that we can't wait for the military solution to evolve. We're spending a lot more time trying to figure out how we leverage what's already out there being developed commercially and implement it in our systems. They briefly mentioned in the prior session about cyber physical security. So cyber physical security of energy systems is also an emerging area for us. The energy security and sustainability as a whole is a big challenge for remaining forward deployed and being able to carry out the mission. And so there's a lot of variables in play there. And we're still, it's a new area. I think there are a lot of opportunities because we haven't found the solutions yet. And I think the final area that I would talk about there is we're starting to rely more and more on digital twin, being able to use machine learning and artificial intelligence to try to design and optimize systems rather than do a lot of build, test, modify processes we're looking towards computer-aided design and digital twin to accelerate development processes. So I think those are a lot of the areas where emerging technologies can really make a difference. Over.
Yeah, great, Michelle. A great focus that you all have there on the Navy side. I'd like to ask Elise. Elise, the Army's approach through Futures Command is I think very focused on the Army priorities for modernization. What can you tell us about what you're looking at across those priorities with respect to energy?
Thank you. Actually, I was hoping you'd segue to me next, because we deal with a lot of the similar problems that Michelle was talking about. We focus on S&T for the 6 modernization priorities. So we have future vertical lift, next generation combat vehicle, long range precision fires, network, air missile defense, and soldier lethality. And the biggest issue for power and energy is just having the available power and energy to do what those new modernized platforms need to do. Because each modernization comes with more sensors, more communications, longer range, longer detection. So all of that requires more power, more energy. And the biggest hurdle is just to get the technology developed to that point. I mean, there's some that they can prove. I came from the battery industry. I just started AFC headquarters in September. So before that, I came from NGCV or GVSC under Army Futures Command, where we looked at a lot of the NGCV platforms. And that was the biggest hurdle, is to get the battery technology advanced enough to provide that long range for those combat vehicles. And when you're looking at, okay, a battery might be okay for a small robotic platform, but what if we're looking at a whole combat vehicle? These huge vehicles needing to be powered off of just batteries, you're really going to need to advance that battery technology so you're not towing a trailer of batteries. So coming into AFC, I'm getting the view of all the other modernization priorities, and they're dealing with similar challenges. It's all about getting that advanced technologies, having the power and energy to power them. And as we get into directed energy weaponry, or like Michelle was saying, robotics, autonomy, then that power and energy is going to be critical to getting it done. And more to that is not just the power and energy to fuel them, but also being able to recharge them. So I was grateful to hear about photovoltaics, getting some power generation going, because we're really going to need that power generation, future power beaming, get better generators, get alternative energy to fuel it, to get recharged up, especially in the battlefield. I mean, you can't just go off of recharging a battery or refueling. You're going to need some way to distribute that energy onto the field and be able to quickly recharge your platforms, or quickly swap out parts or get refueled as you're going, that kind of thing. So, I mean, those are the big areas we're looking at. Energy storage, we're looking at power generation, also looking at power distribution of, you know, you've only got so many generators or so many spots that you can refuel. So how do you prioritize? How do you get them synced up so you know who needs to be refueled next?
Yeah, fantastic. Thanks, Elise. We're seeing some common threads here. I'd like to switch over to Nate Chang from Air Force Futures to talk about what the Air Force is looking at and kind of wrap up this first round.
Sure, yeah. Yeah, to kind of wrap this up, I would say my short answer would be all the above. Everything that Rob, Ken, Michelle, and Elise said, that's basically what I'm looking at as well. And also, as the sponsor for this Reimagining Energy, I don't want to recap all 6 categories, but in a sense, that's really the areas that we're looking at. But from Air Force Futures, again, I think I look at it from a strategy standpoint, right? So not just technology for technology's sake, but so what are we going to apply it to? What kind of objective and strategy we're going after? And for the most part, it applies really to how we can generate combat power. And Dr. Lindsay think of all the keynote speakers brought it up. He's the Indo-PACOM S&T chief. He talked about range, and another way to look at it is not just range, but being able to use power as not a constraint, but as a way to enable a lot of our generating combat power in terms of a combat system, not energy, right? So generating combat power such that we can go after our enemies in an expeditionary fashion. And I think that kind of broadly covers everything that we talked about. Some of that could be energy storage for range. Some of that could be power beaming, like Rob mentioned. And that way we can extend the range. And doing all that in a speed of relevance, right? So we can't just say, like, oh, well, I can charge a vehicle over 10 hours. Well, that might not be relevant in the future war. So I look at it again from a strategic standpoint, and the answer again would be all the above that everyone else mentioned.
Thanks a lot, Nate. I want to, we have just a short amount of time. I want to highlight why this panel is important. So what I hear every time I have a conversation with experts like this on energy is common threads. And Elise said it just a few minutes ago, but you can see common threads run across all the services. You can see common threads run across what our allies are working on, what our international partners are working on. Many times, commercial companies feel like, oh, those military problems don't really apply to us. There's not a lot of common ground for us to work together on these types of solutions. What I believe very strongly is 80, 90, 95% of these energy challenges are common ground between the military and between our commercial partners. So we are really excited to explore these opportunities together. So if we could just quickly run from panelist to panelist for about 30 seconds apiece, if you could tell me where you see the greatest opportunity for us to partner together between the U.S. military, in this case, Department of the Air Force, the rest of DOD, whole of government, and our allies. So let's just go in the same order. Ken.
You know, I really defer to the other panelists that have more of a big picture idea of this than I do. But from my perspective, you know, we've heard power beaming come up a number of times today, right? And I know I've also heard that ARPA-E is interested in power beaming for other applications, such as disaster response, being able to re-electrify grids. And so, you know, the end goals might be different, but the tech that you need to work on is the same across. And so I'm really interested to see how things progress with power beaming, and hope that there's more development to come.
Thanks, Rob.
Yeah, I guess from a more practical standpoint, I think the challenge is always like finding the right connections, the people to talk to have those engagements. And one thing that Navy has been standing up over the past, it's been a year, maybe longer than that, naval tech bridges. There are 12 or 15 of those across the country. And they're run by NavalX, and NavalX's entire purpose is to be a connector, to connect government, industry, academia, so that we're a government that we're aware of what's out there, but that also, as we identify those opportunities, we can be pulling industry in and having a lot more direct engagement and trying to pull some of that technology in. So I would encourage participants in this showcase to identify, if you just look up Naval Tech Bridge online, find the one that's closest to where you're located geographically and reach to them and start having some of those discussions. That they coordinate a lot of different events locally and more broadly. And that's probably the best way within your immediate ecosystem to really get engaged with Navy and find out what some of our specific issues and challenges are, and how you might be able to help with that with your technology solution.
And jump on the networking session at the end of today. Rob, quickly we'll go Rob, Elise, and then Nate, and then we'll wrap this panel up.
Thanks. Yeah, to pick up on your point about the common threads across this, I mean, coming from my environmental and climate background, climate change is effectively an energy issue. 80% of carbon emissions come from energy production and use. And the defense sector is probably one of the biggest energy consumers. I think it's the largest liquid fuel consumer in the US, right? So there's absolutely some really close linkages there and some overlap on the issues. So with the last few minutes, I'll just highlight one particular area of research that's going on at the National Research Council right now that really, I think, holds a lot of promise in this area. It's called the Materials for Clean Fuels Challenge Program. And so a colleague of mine, Phil DeLuna, was speaking earlier today on a panel, a keynote, talking about carbon tech and the promise that the development of new materials holds in that area. So I think, when we look out 10, 15 years at what the energy needs are going to be, to the point about, the energy demand and power demands continually increasing, absolutely. We need to be able to meet that operational requirement, but do it in a way that at the same time is going to address the carbon challenge that we're all facing. And so I think that's going to come through a number of probably three main areas. We're going to be looking at electrification wherever it starts, wherever it makes sense, and the advances that we're seeing in battery, fuel cell, solar photovoltaics. All of that is greatly expanding what can be addressed there. But there's always going to be stuff that doesn't quite fit with that scenario. And we're going to also see big advancements on hydrogen and also in synthetic fuels from CO2 capture and conversion as well. So the Materials for Clean Fuels Challenge Program is looking at the development of advanced materials for CO2 conversion, to create feedstocks for synthetic fuels and chemicals. And it's also looking at industrial scale hydrogen production. And in both of those areas.
Hey Rob, we're kind of bumping up past our time. I want to make sure that Elise and Nate get to make closing comments. So, but thanks very much for that perspective, Elise.
So Army Futures Command coordinates with the other DoD services through participation in things like the Power Sources Technology Working Group and BATNet. And there's other groups of researchers from across the military and industry that are working these power sources technologies. So I think that's the best way for industry to work with Army Futures Command, is keep an eye on those solicitations for power and energy initiatives. And we'll communicate with each other amongst ourselves, trying to keep in touch with each other of what we're all working on. As you mentioned, there's common threads. We're all kind of driving towards the same things. So there's areas of collaboration in that. We do have unique challenges, such as, we operate our platforms in extreme temperatures. We need additional safety if the soldiers, for like man-portable type battery technologies. So really we're watching some of what industry does and either advancing it to meet our military needs, or some of them can be dual purpose with commercial. So we really try to leverage what's out there and advance areas that are not being traditionally looked at in industry, and get with our other DoD partners so that we can all drive towards the same end goal.
Yeah, so look at all these programs for our participants here. Nate, you want to make some closing comments really quick, and then we'll move on
I'll
to
say
the next panel.
Our labs are pretty well connected amongst all the services and the government, but this AFWERX challenge is one of the examples of how we do collaboration. And if you notice through the agenda that there's quite a few different organizations represented, that's also represented in the evaluation process that we went through. And so a lot of times when you look at a challenge, if it's for NASA, for DOE, for ARPA-E, all of us in this energy ecosystem are engaged in that. So I think my closing comment is this is to the industry, continue to reach out and look at every organization's challenges or solicitations, And probably better chances is that we are also, we meaning the Air Force, the Navy, the Army, our partners across the border, we are engaged in those solicitations as well, even though it's the parent organization is, say, a different organization.
Yeah, thanks, Nate. So one thing that we say with AFWERX, we're intending to build lateral lines of communication here. So what we want to do is give you as many trips up to the plate to take a swing at it, and we want you to come back to AFWERX, and we want you to go to all of our DoD partners and allied partners as well, and we want all of you to be successful. So please stay engaged, and back to you, John.
Great, thanks, Yogi. And it's great to see the collaboration and this whole government approach, like you mentioned. It's not the first time we've heard that today, especially the all of the above strategy, which was mentioned on this panel too. So again, Yogi, thank you, and panelists, thank you for spending time with us today on this critical issue. All right, up next, participate in the final opportunity to meet with fellow energy enthusiasts, technologists, and government partners. Navigate once more to reimaginingenergy.afwerx.com and scroll down below the live stream video to our agenda, where you will find a link to join our networking session on a platform called Wonder. Enjoy making new friends if you haven't already, and connecting with some familiar collaborators. We'll meet you back here in about 35 minutes at 16 minutes after the hour. See you soon. We're going to lower the desks as you go. All right, welcome back from our third and final networking session for today. I hope our viewers have made some valuable connections and collided with some potential partners. We're getting close to the end here, but before we wrap up, we've got some very exciting news to share. Now, I won't give any spoilers. I will just let our next speaker take it away. Dan Pike is the Chief of Future Operations and Acquisition Manager at the Office of the Deputy Assistant Secretary of the Air Force for Operational Energy. Dan, off to you.
Great, thanks, sir. Appreciate it. Okay, glad to be here tonight. Thanks for the introduction. Excited about the opportunity to talk with you about an initiative we have going called Energy Prime. So we, a couple of weeks ago, had a webinar on Energy Prime to talk a little bit more with the industry folks about what in the energy space is of interest to the commercial sector that we think might have some overlap with the military. And between that webinar and now, we've actually narrowed down the scope to what we're going to be looking at with the Energy Prime. And there's two primary campaigns, and give you a little bit of suspense here. I'll tell you about those in a few minutes. So wanted to first give you a little bit of perspective on where the Air Force is looking in the energy space and what are the different priorities that we have. So there's a couple of different offices at Headquarters Air Force who are really focused on energy and what it can bring from a capability perspective. You know, what types of warfighting capabilities are going to be helpful, and how do we make a dent in, let's say, energy logistics risk reduction. And so my office, the Office of Operational Energy, has a particularly narrow focus in a sense, but in another sense, it doesn't. So you all are familiar with the Energy Challenge, and that was a very broad look out in the market to see what's available, what can we go after. Installation energy, expeditionary energy, aviation energy, all those things were in play. The Air Force Operational Energy Office, where I sit, particularly looks at aviation energy. And one of the reasons that operational energy is a thing in the Department of Defense is because back in the Iraq and Afghanistan wars, we were losing a lot of soldiers and airmen and sailors, Marines, to fuel convoy and actually water convoy mishaps. And so Congress said, hey, we've got to really look at how we're using our fuel. And where that led them to was we need to figure out how we reduce our fuel demand so we can reduce those number of convoys. Today, that purpose still exists, and that's the primary job of Air Force Operational Energy, is to get after energy demand reduction. And the context now has shifted a little bit. So as you might know, the unclassified version of the National Defense Strategy particularly highlights China as a threat to our nation. And so there's a big body of water between us and China, and flying aircraft in that area is going to be a challenge. And we know from history and things that you can find on Google that China would do well to go after our fuel infrastructure and distribution networks. And so now I would argue it's just as important as it was back in the mid-2000s to reduce our energy demand. And we can get after that in a few different ways. We'll talk about that in a minute here. Another perspective on the Headquarters Air Force staff is an organization called Air Force Futures. And Air Force Futures is really looking at disruptive type technology, and specifically there's a group looking at the energy space. So what are some of the things that we're looking at that perhaps the current warfighters would say, wow, that's really gonna mess up the works for us. I'm not sure if we can handle that. So their task is to look at what can we do that would be disruptive in the sense it's not how we normally do business in the Department of Defense, but if we get there, it's going to be a game changer and a huge increase in capability. And so with those two perspectives from the Headquarters Air Force, then when we're talking about AFWERX, we want to find places where there's overlap with industry and where there's opportunities where we can both work together. One very simple example of something that we're working on in our office. It's a change to the windshield wipers on a Boeing 767. And so again, this is a very simple example. This isn't really gonna make a huge dent, other than it'll save the Air Force about $6 million a year. But this is an example of how there's we often see commercial overlap. Delta flies 767s. The Air Force has a tanker, KC-46, that is a 767 variant. And we received some funds from Congress to look at various drag reduction initiatives. And we found out that if you change the static orientation of 767 wipers from this to this, you can save about $6 million a year across the fleet just by that simple change. And so when Delta Airlines heard about that, they said, okay, wow, if you're going to do that, research and development project, we'll help you with the certification on the FAA side. And then we can go back to the KC-46 and do a simple technical service bulletin update, and you can use our certification process that we'll pay for to expedite the transition of that technology. So that's just a simple example of some of the overlap we see. Now, again, when we're talking about AFWERX Prime, we're looking at a game-changing technology in a sense. We'd like to go after something that's not incremental, but really revolutionary. It's going to change the way we might do business. But then it needs to be a great opportunity for the commercial sector as well, so that we can leverage one another. And so with those things in mind, talk about the two focus areas for the campaign, the Energy Prime campaign. The first focus area is going to be ultra efficient aircraft. So there are some things, if you asked us behind closed doors, that we might tell you specifically that we have in mind when we're talking about that. But depending on who you get behind those doors, you might come out with some different ideas. And so we'd really like to see what you folks think about that. And we need some help shaping what the Energy Prime, specifically ultra efficient aircraft initiative, might look like. There are some reports that you can read. There are some airframes that are digital renditions. If you Google futuristic aircraft, you could find some things on Google. What we'd like to do is, in a 36-month time frame, take those images that are currently on computer screens and put them on runways, and in such a manner that they would have utility for both military and commercial spaces. This also would include not just the shape of the aircraft, but also if there are propulsion systems that you think we ought to look at that would be part of that. We also want to hear what you think. The second initiative is next generation aviation fuels. And so there's a couple different ways that we're looking at this. And again, we'd like to hear what you have to say. And we want to know if we're going after something that maybe doesn't make sense. And a lot of times, if it doesn't make sense for a commercial sector, it might not make sense for the military. So next gen aviation fuels. Can we fly our aircraft on something other than Jet A, the fuel that they have at the airports? Can we do that? It's a big stretch to say we're going to fly all electric large aircraft. As a friend of mine would say, we'll need to create a new periodic table with different electrochemical couples, and so that's a tall order there. But hybrid electrification is a possibility. The next piece is liquid natural gas. That is energy dense enough for us to get after. And so that's another avenue. And then can we take some of these different fuels, liquid natural gas being one, hydrogen being another, atmospheric carbon dioxide, can we convert some of these sources into synthetic jet fuel and thereby diversify our feedstock sources, if you will? So these are some things that we're pretty excited about, and given some of the new emphases in the current presidential administration, we think these are going to be attractive for a variety of reasons. And making a 25 to 50% efficiency improvement in commercial aircraft, for example, is going to be a big deal, and a lot of folks are going to be excited about something like that. And so that's what we're thinking. And again, we really appreciate any input that you have for us. prime.afwerx.com is the website, and you can find information on the energy challenge there. Gonna give it back to Colonel Nate Diller, who we're very appreciative of his support as the AFWERX director, and look forward to showing him that Energy Prime is something that's worth going after. Sir, over to you.
Super Dan, thanks for the great work that you've done in helping us develop the idea. Thanks for everyone for joining today. Exciting work that is happening here. Really looking forward to the great ideas that are moving forward. Looking forward to continuing to bring the ideas that came from this outstanding effort with Reimagining Energy into our Energy Prime, hoping to be able to scale those ideas. As many of you know, if you have those ideas that are available and would like to partner right away, we still have an open call for our next round of small business innovation research and small business technology transfer programs. If you go to afwerx.af.mil to find those things, and we continue to have at afwerx.com opportunities for you to engage in those prime discussions. So thanks for your time here today, and we really look forward to the ongoing partnership with the outstanding innovators out there. John, I'll hand it back to you to close us out for this evening.
Thank you very much, Colonel Diller. Thank you for that. We really appreciate it. And that was a great way to finish things up there with Dan Pike and some of the things that they're putting out there, especially as, you know, prior to C-17 pilot. It's good to see some of the things that we're doing within the fuels and within the energy. So anyways, thank you again for joining us at the Reimagining Energy for the DoD. I know we have more than 170 companies who have made it to this round. So congrats to you once again, and our thanks to all who participated and to those who submitted proposals. I know some may have been expecting to hear an announcement today regarding selections for the next round of the Energy Challenge. So just a quick update, we will not be making any announcements today, but our intent is to notify those who have been selected for the next round within the next 2 weeks. So our intent is to notify those who have been selected for the next round within the next 2 weeks, and we will work to inform you as soon as those selections have been made. So this concludes our DoD Reimagining Energy Challenge. It's been a very exciting day, a very inspiring day for many reasons, exploring how transformational change can happen right now in ways the DoD uses, transfers, and stores energy. I think my greatest takeaway is that solutions, I think, for a better decarbonized future are here now with more rapidly emerging technologies on the way. I've heard this is important for 3 reasons. 1, it's the right thing to do for our planet and for what we leave behind. 2, it's a national security imperative, as others, both allies and adversaries, are making seismic moves in this space. The decisions we make over the next 3 to 5 years will shape our energy future for the next generation. And 3, the DoD, the Air Force, we're in a great position to lead by example, to do things like Dan just said are revolutionary. We use the most so we can change the most. And because we use the most, even a little change will have a significant impact. So before we sign off, again, a final thank you to the AFWERX team, both here in Las Vegas and across the country. Colonel Diller, thank you, sir. General Highnote, and to all of our speakers and panelists who helped make today's event a success. Thank you again. See you next time.